So DevOps, what's interesting about it is that the word in a way is somewhat confusing because you hear it all the time. Hey, DevOps, it's like a buzzword, but a lot of times it's hard to really articulate, well, what is it? I think one key thing about DevOps is this word automation. And you could think of DevOps in a sense as a marketing term where some of the stuff that's happening is actually pretty intuitive in terms of software engineering. Is really a core trait of a good software team is that, or a software practice, is that you're automating things as a general rule, that you don't leave things to humans that can be done with a script or a build server. And so how does this automation actually occur? So again, it does happen through the continuous integration and continuous delivery pipeline. And in particular, these are done through a build server. And really, this is the heart and soul of DevOps. So you can't really say what DevOps is without talking about what a build server is. And there are some more, we'll call it squishy terms, which are important. So we'll put the squishy stuff here. So we'll say, things like teamwork and good leadership. It doesn't mean they're not important. These are really important things to consider in creating a good culture, but they don't really have anything to do with the technical parts of DevOps. And so I think it's good to separate those things and maybe break them up into sections and say there's a teamwork component, which is important, and you have to have this component to it, but there's also a technical component, and you can't hand wave on either one. They're both important, but separate. And in case of DevOps in particular, with the automation, this build server is something that's very important to discuss. And one of the things that I wanted to just briefly talk about is the types of build servers, because this is a common confusion, I think, that I hear a lot in DevOps is this term build server can be confusing or overwhelming. And there's a few different flavors. One is open source. And with open source, there is probably the top build server option here is Jenkins. And one of the reasons why people like Jenkins is that it has a long history of being a successful build server, and also it's just a binary. So Jenkins itself is a WAR file, so it's a Java file, and this Java file you can just throw it up on a server somewhere, and it will just start doing things for you. And it can be as straightforward as just running commands inside. Another component of build servers is also these third-party SaaS servers. And in the SaaS land, really the main players here would be GitHub Actions is probably the largest choice now. There's other options as well, but GitHub Actions is probably one of the dominant build servers just because of the market share that GitHub has. Another option, though, in that space would be Circle CI. So Circle CI has been around for a while, and they could be another option. So why would someone use a SaaS-based build server and not Jenkins? I think one of the reasons that people would use a SaaS-based build server is that the limitations are acceptable for the kind of project that someone's working on. So for example, if you're building web applications or you're building something where you need a Linux-based container to execute your code, there's a lot to like about this SaaS build server because I don't have to maintain Jenkins. And this is the downside of something like Jenkins, is that I have to actually maintain it. And so this is just more work for me to have to go through here and make sure that Jenkins is up. There's no problems with it. But with a SaaS server, I can just say, look, things are okay because this other company, I'm paying them money and they're going to make sure that I'm able to execute my code. So that's one advantage. The other advantage is that the feature sets. A lot of times these SaaS build servers are constantly coming up with new features, and building more things. Like, for example, GitHub has security, right? They have security scanning built in, or they may come up with a fancy way to collaborate with pull requests. So I think that's one of the advantages of using a SaaS-based build server, and in many cases for code quality itself and for collaboration and software collaboration tools, the SaaS-based build servers are probably best in class. But I did want to talk about a slightly different version of build servers as well. And the other build server option here is, and we can just put this on this page, is cloud native. And this is an emerging category that's less understood and less talked about, but it's actually a very interesting category. So every cloud, whether it's AWS, GCP, or Azure, they all have their own cloud native build servers. So you may be asking yourself, what we have got Jenkins, it's open source, and then you got SaaS, you got GitHub Actions, Circle CI. Why would these cloud providers also build a competing product? And part of it is that in the cloud native world, you're getting deep integration with their cloud platform. And that's really the big thing that you'll notice about the cloud native build servers. So what are the examples? We've got with AWS, you have AWS Code Pipeline / Code Build. With GCP, you have Cloud Build. And with Azure, you have Azure DevOps Pipelines. And the deep integration makes it so that if you're doing serverless deployment, or you're building, containers, or you're doing something that cloud has a very specialized feature for, the cloud native build server will probably give you the best experience. So in a nutshell, that's one thing that is really important that I don't hear talked about enough with build servers, is that there's these different flavors, and it's important to be very specific about why are you choosing one type of build server versus another type of build server. And in fact, some cases you may want to use a combination. You may want to use the GitHub Actions for maybe the code quality and the security scanning, but then use the cloud native build server as well, use both at the same time, and that can do the continuous delivery. So let's now get into, now that we've defined the build server and the build server types, let's briefly talk about the difference between CI and CD, which is another common point of confusion here. So in terms of CI, and we have CD, the big difference is that CD is also confusing because it could stand for either delivery or it could stand for deployment. Most people are, I think, gravitating towards the word delivery over deployment. And we'll get into that in a second. But first, let's define what is continuous integration. So this one's a little bit easier in that it is basically interacting with the build server. So what it does is it tests your code automatically and builds your code automatically. These are some of the things that a continuous integration server does. Maybe it checks for quality of your code through linting or security checks. But basically, this is the point where you can kind of have this feedback loop that's constantly making your code better. Another word for this, there's a Japanese word called kaizen, which is a way of continuously improving something. And that's really what continuous integration is why would you not have unit tests and functional tests and linting and compiling happen every single time you make a change to source control. So we have source control here, and then we have this feedback loop of just this constant improvement. So or kaizen. That's really the core concept, but it has nothing to do necessarily with the deployment of the software. It's its own independent component, but Now let's move on to continuous delivery. So continuous delivery means that your code is in a deployable state. So that's really the key difference between automatically deploying your code versus making it in a deployable state. And in order to have your code in a deployable state, really there's a couple different prerequisites. One of them is that you do have CI, right? So that's, even though CI in itself is a completely separate component, you do need to have it to make your code deployable. And so that's right. You wouldn't want to have code that doesn't build, or code that has massive bugs in it to automatically go to production. Only someone who doesn't want their software to work would do that, right? It's a very bad idea to just constantly throw bad code into production. Instead, you want to put good code into production. So this is a gate right here. This is a quality control gate to your deployment process. The other component to always make sure your code is in deployable state is IAC, or infrastructure as code. And why is this important? Well, one of the reasons why it's important is that, especially in the cloud world, you can define your entire infrastructure in essentially a config file. So a lot of times this config file is, let's say, a YAML-based config file, and it will have every single component of your network laid out. And the reason why this is important is that you are not going to guess here. So we can just say guessing that your infrastructure is ready to go goes away with infrastructure as code, because you don't have to ask somebody on your team, hey, did you deploy 3 nodes for the front end, and did you put the load balancer on there, and does it respond to requests? It's actually defined inside of your project, checked into the project. So these are really the two key components, is that you're programmatically controlling your infrastructure via code, and then you're also have this quality control gate. And now let's get into the difference between delivery and deployment. Really, it's the option is the difference. Is really most companies probably would prefer, if they fully know the environment, to do continuous delivery versus continuous deployment. And what this means is that your code is always in a deployable state, but you have the choice whether you should deploy it. And I'll give you a good example. I was running a company at one time in my career where we had continuous delivery set up, and I remember someone in my company was working on a database option. They had done what they thought was a good job at testing it. They deployed it to a staging environment, a load test pass. But what happened was there was a subtle bug where a bunch of user records were permanently deleted in a schema change. They then got on the bus, took off, and then later we're like, wait, what's going on here? There's a big problem. And so because a human was actually not checking, and at the time we were kind of exploring the differences between whether we want to do delivery or deploy or continuous deployment, and we didn't have a human check it, is that we had a problem like that, slip through the cracks. So I think probably the dream scenario for most companies would be to always have everything automated. So you shouldn't have an excuse to not automate your code, but that there's a human somewhere inside, and maybe we just draw a human here, is that it's essentially human plus automation is continuous delivery, right? So don't make excuses and not automate your codes by saying, hey, we have to have humans check things. You want both, right? So you want your code to be automatically able to be delivered, plus you want to do a final check. And in most cases, that's a good idea in deploying your software, is to have some humans in there making sure that you're not deleting customer records, or there's some kind of quality control list. You want to make it as automated as possible, but that's kind of the high level in terms of CI and CD. So from there, I think we can, now that we've defined that, that's really the core of automation. I guess the last thing I'll say quickly, and let me now go to the human aspect of it. So if we say, DevOps here, we talked about the technical stuff, which is not squishy, right? We have the technical. In a nutshell, it's basically automation. Technical is the automate. That's if you could define it in one word, it's basically automate. And then the human side of things, or the management side of things, the key things here are that there has to be an effective team, and we talk about this in the book Python for DevOps actually. But one of the things about, in order to do automation, DevOps, is you do have to have things that are common in high functioning teams, like support from the people in your company. So if the CEO of your company says, hey, I don't care if things have tests, I don't care if the code is high quality, just get it out there, right? That's not effective management, and you're not going to have an effective culture. So there has to be support from the executives in the company to do things right. Also, if you have, let's say, toxic team members who, maybe what they're doing is, at night, checking in code at 2 a.m., bypassing the build server because it slows them down, you're not going to have an effective DevOps culture. Or, another thing that could happen in terms of management is I call this the hippo problem, which is really a big problem in American culture. And this stands for the highest paid person's opinion. So if whoever gets paid the most money makes all the decisions instead of listening to the data, then that also is going to be a detriment. So I don't want to discount that these are real problems that have to be addressed. But they're distinct in that they're management problems that hopefully companies will take seriously, but they're separate things. Now together though, the automation and the quality control and the deployment, that itself has to be done. And in addition, there has to be an acknowledgement by the management, the technical management in the company, that you need to have an effective team in order to implement DevOps. So that's kind of it in a nutshell. That's the quick tour. So let's get into now some code. We did some theory. In terms of code here, I'm going to share this notebook, which I think has already been in the resources. And we can start off with just kind of a review here of some of the stuff I just talked about. So according to AWS, the DevOps best practices are continuous integration, continuous delivery, microservices, monitoring and logging, basically using data to make decisions, not the hippo, the highest paid person's opinion, and then doing communication and collaboration. So we basically talked through this. We covered that. We also talked about continuous delivery. Microservices, the reason why this is AWS's opinion, but I would agree with their opinion here, is the reason why this is so important is if you build really small tools, those small tools have a less chance of having a problem. You can isolate things. So let me just talk about that real quick, because I think that is a good topic to just cover as well and be very specific about it. So why is it that you would want to build microservices? What's the reason for this? And I would say even you could define it as microservices and tools. And what I've found in both my career and also teaching this topic to many graduate students around the world is that you do want to build small tools. And the reason why you want to build small tools is that they're a way of isolating the complexity. And this is probably one of the common things that I see, again, in my career, or I've seen in student projects. If you want to put a recipe for, we'll call this an anti-pattern to not build something, what would be the anti-pattern that I've observed? One is monolithic projects. So by monolithic, what this means is that you're basically putting this giant system together And unfortunately, what happens is that by making something very complex, there's a very high chance that it won't be able to be debugged. And this is just classic problem in building these systems. Another thing that's kind of another anti-pattern here that's associated with this is, working to the deadline. That's another anti-pattern that's also associated with microservices. And why is it associated? Because if you're able to break things up into pieces, there really isn't a deadline. You're able to actually isolate and build a small tool or a small microservice, where if it's a monolithic application, kind of by its nature, you're just always working on it. You're always working on it. You can't divide it into pieces. So, and then lack of automation. I would say these are probably the anti-patterns that I notice that crop up when a project fails or a student delivers something and it just didn't work, or if companies I've worked at where I've had to fix things is that these are some of the components, and really the microservices and tools is actually a way to solve that, because it's actually an intentional way of limiting the complexity. Another way to think about this is that you're mapping a function to a task. And this is also a key component in the modern world of Python, is can you map a function to a task? And if you use, let's say, a Flask application, it could just be a decorator on top, and then essentially this is your route, and then you put in your API. And what's nice about this is then the lines of code could be 3 lines of code or 4 lines of code, and it's really easy to look at. You just look at the code and there's a route, and then there's a function that does something. Where if it's potentially a massively object-oriented project, maybe even say massive OO is probably an anti-pattern in the cloud world as well. If you're building a framework for somebody, sure, object-oriented programming is great. But if you're trying to build something that's a service that's going to run for years, massive object-oriented programming could really hurt you in the long run. So those are just some of the ideas of what I've seen, is that a microservice is a way of actually intentionally minimizing complexity and getting things done in pieces. So let's see, what else? Monitoring and logging. We basically talked about communication and collaboration, but monitoring and logging is another one that is actually a critical component of DevOps that really is actually also in some sense misunderstood. And let's just briefly talk about this as well. Monitoring. So one thing with the cloud in particular, and I think most companies know they need to be on the cloud or they have some kind of cloud strategy, is if you're in the cloud, by its nature, you're going to have a need for better instrumentation. So the cloud will require better insights because everything, you can't, in some cases, SSH into another machine. So you can't SSH into another machine and see that there's something going on. Let's just say this is an EC2 server. In that case, sure, you could potentially SSH into there, run the top command, and then debug things. But if it's a Lambda function, for example, AWS Lambda, you're not going to be able to SSH into it. And that bothers people, but it really shouldn't bother people, because it's actually exposing the fact that you need good logging. And if you have proper logging and instrumentation, you don't need to shell into a machine to see what's happening. You can actually just visually look at the data. So this is, in a nutshell, monitoring and logging is something that is a comprehensive strategy that has to be undertaken by a company. And in fact, this is really data driven. So is your company data-driven? And do you care about looking at the data, or are you making decisions based on some other thing? If you don't do logging and monitoring, you're not looking at data. And I think that's the key takeaway here. Is I think data science in particular is this hugely popular topic, but I think sometimes there isn't the connection made between the fact that data science and monitoring and logging have a lot in common. Basically, it's data science for your software. That's why you do monitoring and logging. So that basically, I think, gets us past the theory component. So let's get into some actual code now and talk about IPython, Jupyter, Colab. I actually think IPython is one of the more interesting tools for DevOps because it's an interactive terminal, and it's a great way to play around with code. And it actually predates Jupyter. So this is Colab Pro, which I'm using right now, is built on top of the IPython kernel, and in this case, I'm just using a web-based version of IPython. And so what I like about it is one thing that you can do is you can actually execute shell commands. So if you want to play around with the shell, a Jupyter notebook or Colab notebook is a great way to do it. And in particular, one thing that's neat about this that could be really handy in building quick scripts for DevOps is that you can take the shell output here and you can assign it to a variable just like that. You can say, there we go, type var, and then it will give you this slist property. And there's a couple methods that are associated with the slist, and one of them is the grep. So for example, because I have this variable that's an slist, I can actually go through here and grep for all the stuff that's inside of there. So it's really a combination of this fancy Unix grep command plus Python, and you can mix them together. There's also fields as well. So if you go through and want to split things by white space, you can do that. So I think this is a neat little trick that if you are using IPython or Jupyter, you can do it to maybe look at the output of something, or build a quick and dirty monitoring tool. So if you're not familiar with Jupyter, although it looks like many people probably are, it's got many flavors of Jupyter. And in particular, there's Jupyter Hub. This is the open source stuff. But there's also things like Colab Notebook, Kaggle. And then this is another thing that you'll notice on all the cloud platforms. And SageMaker's got a good example of this, where the notebook itself is actually the center of the universe for MLOps. And in particular, and let me just talk about that real quick as well, is that one of the emerging job titles right now is an MLOps engineer or ML engineer. And with MLOps, it has a lot in common with DevOps. And with MLOps, the center of the universe in cloud platforms, at least, and this is really the case with AWS, GCP, and Azure, is this Jupyter notebook. So it's pretty interesting actually how all this happened. I mean, this is happening in real time here, but basically Jupyter in all these cloud platforms is the center. And what happens behind the scenes is that you'll have clusters of machines that get forked off to do training. You can also do deployment after the training, and that can invoke also clusters of machines. You can version your models as well. So DevOps type things that you would think you would do in a regular software project happen using MLOps. And again, the center of the universe is this Jupyter notebook. So there is a real key reason to master Jupyter, especially if you want to get involved with MLOps, is that it's really going to be the steering wheel for things involving machine learning. And I mentioned this, right? There's all these different versions of Jupyter Notebook. So let's get into Colab just briefly, since I'm using it here. I think it's not a bad thing to have in your toolkit. And what I like about it is that you can do TPU and GPU runtime. So if I go through here, I can go and change the runtime, and I could test out an NVIDIA-based GPU workflow, Or if I wanted to do something with TensorFlow, I could actually do a TPU. So where this could come in handy is if you're working with a machine learning model that maybe the data science team developed, you could pull it into Colab, kind of play around with it a little bit, make sure that the model is going to work with maybe a Flask app, and then dump it back out again. So I think this Colab Pro is a pretty good tool for technical documentation and also for testing things out in a company that does machine learning. Maybe a couple other things I'll show you about Colab is that it's got this magics command here, which is pretty neat, and I use it to benchmark code. I also use it to create aliases. So if I want to create an alias, right, I can actually go through and do that. I also can run a who command. And so this is another one that's kind of neat, is if I went through here and I said var and make a variable, notice that I can see every single variable that's in memory right now by using the who command. And so that can be really handy if you've executed the notebook several times and maybe you're not sure what variable you're actually using. You can actually then just find the one that's in memory and then say, oh, okay, yeah, what's in that variable again? And you can take a look at it. Another one that I use that's a magic command that's slightly more exotic that you might want to try out is that this %% write file. You can use Jupyter actually as like an IDE, in that what I do here is I write a Python script. So I just write it out to a file called magic stuff. And then if I cat this, you can see it just put the code inside of this file I created, and then I could actually invoke it, right? So if I go through here, I can now invoke this. So it's a quick and dirty way to, let's say you're working with, you're looking at a cluster of Spark nodes or something, and you're like, boy, I need to figure out what's going on here. Let me write a quick little Python script. You could just write it inside of here, dump it out, and then run it. If it works, you could go put that into production somewhere. So it's kind of a speedy way to prototype code. You also can install packages in Jupyter as well. So here, I'm installing PyLint, and then if I wanted to use PyLint on that last module, I could do that. So there's a lot of really powerful stuff you can do with Jupyter. I think that helps with DevOps. Another one that I like is that you can also execute blocks of Bash, which could also be helpful. In some cases, it's actually much more convenient to just dump some Bash code out and write a small little Bash script. And you can do that. You can just kind of keep it in a block here and then refer to it later. The other thing you can do is you can actually mix Python 2 and Python 3. This is less common, but it's nice to know that this feature exists. I've had this happen where I've had to deal with someone's old machine learning project that was, written way long time ago, and it's all in Python 2, and it's too much work to convert it. I just want to run it and look at a result. So I'll just put a block of Python 2 and mix it and match it in my Colab notebook. Another thing that I'll do as well is create tags, right? So I can create tags here, and I can do that with HTML. So there's a lot of great things that you can do with Colab Notebook. And one more I'll show you as well is that you could actually even programmatically create a spreadsheet, and dump stuff to it as well. Let's just briefly mention that Python itself. One other thing that is kind of a neat thing that maybe you're not doing is you can invoke it with -C, and you can run snippets of Python code. And so that can come in handy if you're just on a regular machine somewhere, or if you're in Colab. This can be actually a neat way to just build like quick little one-liners. Okay, let's get into a review of some of the intro concepts in Python now. And we won't spend a lot of time on this based on what I saw from the poll. But basically, procedural statements, the key idea here is that if you wanted to do something in Python, you have a one-line statement. In this case, if I want to print something out, I put in the word print. If I want to declare a variable, I can go through here and just assign it to a variable. If I want to do multiple things, I want to build, for example, multiple procedural statements. I just have a variable, another variable, I'd have a print, another print. So basically, sequentially or procedurally building code in Python is completely fine. And in many cases, actually, it is a great way to build things. There's no reason for very small scripts that procedural code isn't acceptable. You can also add things together, both strings and numbers. You also, if you're going to build something slightly more complex, a lot of times you'll have a for loop, and you'll see this a lot where there'll be a list. In this case, I've got a list of different belts here, and I iterate through and I print things out. So this might be something, this could be machines, for example, and you're going to, look at the uptimes of machines. You could write a small little script with the different IP addresses and run something on them. But in general, this little 5 lines of code here, 5 or 6 lines of code is a typical small script that you could put into maybe a command line tool or a Lambda function. With strings and string formatting, the key takeaway here is that Python basically can do everything. So with strings, you don't have to write capitalization methods, encoding methods, uppercase things. In general, the idea here is just let it do all the work itself, right? So in this particular example, we can say this is a string, and I can just split up the string by just using the built-in method. If I want to capitalize it, right, it'll take that first letter and capitalize it. So I think this is a big takeaway, is it's a batteries included language. So don't go through and build all the stuff yourself out. Be efficient. Use the built-in library. Tons of stuff you can do, like check if it's numeric. Swap cases, all kinds of stuff. So and then in this case, for example, turn a string into a list. This is typically, if you're going to start to do more heavy lifting in Python, this is a lot of times with strings, one of the things you'll do is you'll split it up, and then you'll start, manipulating it. Now you can split it up by not just commas or white spaces, but you can also pass in other things. So if it was hyphenated, for example, you could split it up, or it had a comma into it. But in general, if you want to do some quick and dirty string processing, splitting it is a good place to start. Now, slicing as well is another thing that is important to be aware of, is that you can actually slice strings by getting the end or the beginning. And this is also really handy for DevOps stuff. You may be looking at a log file and you want to slice off a piece of it. Well, you can easily do that by, pulling it into reading the file, and then line by line, taking the first part of it, like the left or the right of that line. You can also add things together, and this is called string concatenation. The performance is not great, and that's why typically people don't use it in scripts. But just for playing around, it's not bad to be aware of it, and you could see how you could use it. I used to work with PHP developers that did a lot of front-end development. I know that this is a very common PHP pattern, which is, I get it. It's actually quick and dirty, not the best in terms of performance, because you're actually kind of reusing it over and over and over again. It's a slightly inefficient way of building a string, but you can do that in Python. The better way to do this is actually with string formatting. So in this particular example, you would say this is a string, and I could do a print s statement, and I could swap that variable for this percent s. The problem with this is C style string formatting, is that it's really error prone. It's really common for people to forget to put this there, forget to put this percent. And so there's a new way in Python that's actually pretty clever called f strings. And the way you do strings is you put this f here, and then you put the quotes around it, and you put the curly brackets. And why this is recommended is this was introduced in Python 3.6, so it's still fairly new, but the performance is much better, and I think it's much more intuitive. So if you have the ability to run Python 3.6 or higher, I've actually defaulted to just everything I do now, I do with F strings. And you could do it with triple quotes as well. Here's an example of that. You could then go through and do something slightly more complex, like build a phrase and then strip out the empty line breaks, right? Also, Python can do numbers and arithmetic operations, right? I could do something like this. I could build a statement, like a word problem. I can, build like a scientific equation here. I can use decimals. This is actually a neat little library, decimal. I can say get context, and I can actually convert things from a decimal to a floating point number. And then I can actually tell it to have a certain level of precision, right? I can say, here we go. I want you to do a repeatable decimal up to 5 digits. Exponents, there's 2 ways to do it. You can do math, at least 2 ways to do it. Or I can say 2 *** 3. So if you're dealing with exponents, this is actually pretty neat. A regular one is just 1. Converting different numerical types here. You can, one good thing that I think if you're not familiar with Python, or even if you are, you may not be aware of this, is that you can say type here, and it's a great way to actually debug something. If you don't know there's something failing in a script, or you're figuring out, hey, what's going on here? A lot of times if you print out the type, it can give you a hint why something's got a problem. You can also run type on things like objects, and it'll show you, oh, look, it's an object. You can round numbers. This comes up a lot as well, and you could do it many different ways with modern Python, like built-in round, NumPy round, pandas round. But the difference here between these 3 different rounds is that I could actually benchmark it, and this might be something to consider, especially if you're building something that runs on servers, like monitoring code or something, is to just do a quick benchmark. A lot of times you'll be surprised, like the built-in round here, this is 423 nanoseconds, is much quicker than the NumPy round or the data frame, because this has no overhead, and it's a framework, so it's got other things inside of there. So someone might naively assume that NumPy, because it's a scientific computing library, will be quicker, but it's not. In this particular case, it's actually slower. And then I guess the other thing that I'll just bring up really quickly here is that lists and dictionaries. Really, the 2 main things with Python are lists and dictionaries. And you can almost do everything with those, especially in the DevOps world. And so a dictionary in particular, if you had to just pick one thing you were going to only use in Python, I would say it would be a dictionary, because basically you can do everything with the dictionary. And you can define one by putting brackets here. Here's a example dictionary. I have key value. And if I also want to programmatically build one, I can do it with dict. So this can be handy if you're going to, build some kind of fancy dictionary. So how do I use it? One way to use a dictionary is to use .items, and what it does is it pulls the key and the value out, and so I can then loop over it. So in this case, this is the key, and this is the value, and then I could do something with it. In this case, I say the arm bar is an attack on the upper body, the arm triangle is an attack on the upper body. Where I can go through and pull out the key parts. I can also filter with a dictionary, so for underscore, and I can just throw away. In this case, I throw away the key and I just get the value of the dictionary. And I also could do a filter by doing a for loop and then looking for a particular match. So I can say, look, if the lower body is in the key, basically print out the submission. So print out the key. Otherwise, I don't want to look at anything else. So these are the lower body submission attacks in Brazilian Jiu-Jitsu, heel hook, knee bar. And then you also can use keys or values. A lot of times I'll use this if I have something I just want to look at visually as much as possible in a Python dictionary. I'll just look at the keys or look at the values. In particular, keys can be a good way if let's say you're using the AWS Bodo library and it gives you this giant dictionary back. You may want to just first say, dot keys on it so that you can see, okay, what are the things I could look at that I even care about? Because if you just print out the dictionary, it's too much. So then you can subset it and then look at it. So this is actually very handy for DevOps. Another thing you can do with keys is you can say, if this word is in the dictionary, do something. And this key lookup is very fast. Python lists, this will maybe be the last thing we briefly talk about before we take a quick break and then go to Q&A, is that they're commonly used in Python. They're for sequential collections. And here's an example, right? A list of positions in Brazilian Jiu-Jitsu. I also could just programmatically create it. And you'll see this a lot in scripts, right? If I'm maybe, again, looking through some log files and I want to find all the bad things that happen on a server, I could look for a word and then append the bad things to a list and then later, email that out, right? Another way to use, let's change the runtime so it won't irritate me. So the very performant way to create lists is to use list comprehension syntax as well. So all a list comprehension is it's a backwards for loop. So you just basically take the bottom of the for loop and you put it, you kind of like unravel it and you put it at the beginning. And so in this case, this would say, for guard and guard split, and then it would apply the string formatting to it. So the reason people use this is the performance. You can get very high performance because this is a tight loop and it will run it in a more optimized way in C. Loops as well, you can do the same kind of, at least you should be able to, unless I didn't run that. Did I not call that list? Maybe I didn't call that list. There we go. So you can also filter. You also can slice as well. And this again is handy for looking at log files, right? Is let me just pull pieces of the list out and I just want to look at one part of it. You can put, from the end or the beginning or even a slice of it as well. Another thing that is less commonly used, but it's good to know about, is you can basically do multi-dimensional swapping. You can throw things around, and so in this case, I have, this is the top, right? Dominant, neutral, weak. But look, then I swap it to, I basically rotate this, and I can rotate it so that those three items here now go left to right instead of up and down. And then sets are less commonly used, but are interesting in that one of the things you can do is actually dedupe. So if you had, let's say, a bunch of custom IP addresses from some server logs, you could just dump them into a set and it'll dedupe them, right? Which a lot of times that is actually irritating to deal with duplicates, but the set method in Python just automatically solves it for you. And you can do fancy things like find the difference between collections, and there's an example of how to do that. So the final thing here before we take a break would be that you go through and try this out. If you can get a chance, is write a dictionary with a mutable key. So here's a good one here, and then this one is a mutable list here. And if I throw that in there, notice what it says. It says it's an unhashable type. So with a dictionary in Python, the big takeaway is it can take pretty much anything except the key itself. The contract is that the key can't be something that changes because the dictionary wouldn't be performant anymore. It's making the assumption that the key will never change. Also, it's just important to be aware that classes can mutate, right? And there's some things you can do with classes that are a little bit spooky, like you can put, for example, a class instance into a dictionary. I'm not sure why Python lets you do that necessarily. It seems like a bad idea, but you can do that. We should be back from break here. And let me just go through some of these Q&A questions here. So one of the things is, let's actually just put this into the window so everyone can see this. And let's send this Q&A question, push this to slide area. So one question is, what is continuous integration? And then also, does continuous delivery or continuous deployment, what's the difference between these two? So yeah, I believe I did. Let me just share my screen and we'll just, since some of these are conceptual, I'll talk about it as I'm answering your question. So I will go to screen share real quick and just clarify that real quick. So the key difference, which I briefly did mention, but I'll just reiterate between the difference, is that with continuous delivery, it means that your code could be deployed, but with continuous deployment, it means you always are deploying it, right? That's kind of the key difference here. So let's see here. I'm going to just draw this up real quick. In terms of continuous deployment, here's deployment, here's delivery. This means that basically as soon as it hits, let's say GitHub, your code would automatically just go to production. And as I mentioned with the story of the database that deleted customer records where I worked, that's one of the downsides, is that if you automatically just put your code into production, delivery though is similar, except for, let's take GitHub here, and you could actually have multiple branches. You could have a master branch, you could have a staging branch, and then you could also have a production branch. And what could happen is that the code would always get deployed here. It would always get deployed here, but then this one, you don't deploy it until a human will merge it in. So maybe the human here will first do some checks, like, hey, let's just double check that things are actually going the way they should, and then they do the final switch. So it means that it's still automated, but the human does the final push. Great question. And let's go to this another question here, which is, what is cloud native? So let's talk about that. Cloud native in particular refers to, let's just go here and just say cloud native. So cloud native refers to the concept of it is first originated into the cloud. A good example of this would be, AWS Lambda is a good example, which is a serverless function, which I think we'll have some time to talk about those or show them later. That's not capable of running on your laptop, right? The concept of a Lambda, isn't, I guess we'll just say it doesn't fit, because that functionality is only available in the cloud. So you can think of it as the cloud enables that technology to exist. Another example would be maybe S3 storage. So what is native about S3 storage? Well, it has 11 nines reliability. So what that means is that it's 99.999, 11 times reliability. You can't have that on your laptop because your laptop you don't have that many copies of it. So it's basically functionality that only could exist by being in the cloud. Another question here is about Kubernetes. So let's talk about that question. So I hear a lot about Kubernetes related to microservice. What is it? So Kubernetes, in terms of microservices, let's just briefly talk about Kubernetes here. The container world, in particular, has basically two components that are popular right now. You have the Docker runtime, and then you have the Docker also format containers. So Docker format. And what this buys you is that you can, inside of a config file, here, this would be a Docker file, you can define a subset of what happens on, let's say, Linux, right? So it's a smaller subset of a Docker of a Linux operating system. So that's really what a container is there's a breakdown where you have the physical machine, and that would be called metal. That's the highest level. That's like your laptop. Your laptop, though, you can run virtualization. And so on the cloud, a good example would be EC2. That's a virtualization. But then inside of the virtualization, there's another layer, which is the container layer. So a virtualized machine can also contain multiple containers. And so the big difference between the virtualization and a container is a container is much more lightweight, and it's designed to be programmatically controlled. And so that's why it's very handy for building microservices. And also, you can look at the Docker file and see exactly what's in it. But a virtualized machine, that it's much more difficult to see. What is this? What's in there? It's basically a giant image. So a Docker file itself, once you've got this set up, you can deploy it to a Kubernetes cluster. And so with Kubernetes, the key here is that you basically have something that can run lots of containers. And so this orchestration system here, has got the ability to run tons of containers. And so the microservice component would be that if you build out a Docker file that runs Flask, for example, you would deploy that to one of the containers, and Kubernetes itself would execute it. And so Kubernetes can run anywhere. So Kubernetes can run in a data center, it can run in the cloud, it can run on a laptop. But the core idea here is Kubernetes is the orchestration that orchestrates these containers. And the microservice itself, you could have tons of microservices running in Kubernetes. Okay, let's go to the next question. So can we run Bodo and Colab? Yeah, sure. You can actually run Bodo 3 in Colab. That's as long as you load the API keys. I've definitely done that before. And another question here is, what is the difference between Jupyter Notebook and Colab? The key difference between Jupyter Notebook and Colab is that, and I guess I could just maybe draw that out since I'm in here. The key difference here is that it's hosted, right? So in this particular example, we have Jupyter, and then we have Colab. It's basically the same, except for with Colab, it's hosted, and it also has access to GPUs and TPUs. And then it's got a few, special features from Google, but it's mostly backwards compatible. I find it to be very handy for teaching at a university because I can actually check in Colab notebooks into GitHub and then share them with students. And so it's a pretty good collaboration tool. It's kind of like, you can think of Colab as Jupyter plus Google Docs. That's probably the best way to think about it. Just imagine Jupyter Notebook, and then you just add the Google Docs suite, which is a pretty powerful suite, to Jupyter, right? That's basically the combo. And another question here is, let's go down. Okay, what's the difference between, what level of Python proficiency is required for a DevOps role, medium or high? So that's a good question. I think that for DevOps, really, actually, I would say probably medium is completely fine. You really don't need to be a Python guru to do DevOps, because a lot of the code is very function oriented. So I think you could really just need to know how to build a function and know a little bit about Python. And I think the concepts of automation are probably more important than being an expert on the syntax of Python. So I think medium is totally fine. And another question here is, what's the difference between GitHub and GitHub Actions? Good question. So GitHub Actions, GitHub, and we will get into this in a second. So what's GitHub, and then what is GitHub Actions? So GitHub is just managed source control, right? So this is just a hosted source control. So most people are familiar with this. So what's GitHub Actions? So GitHub Actions is the ability to run a build server. And so GitHub Actions will allow you to do things like, test your code, lint your code, and actually deploy your code. And so really, if you're familiar with Jenkins, it's basically like a hosted Jenkins. That's one way to think about it. If you're familiar with Jenkins, it's basically the ability to do things in response to check-ins in your code. So it's their third-party build server. Another question: how does Ansible help with ML ops? I think any kind of configuration management language will help you in building automation. So the core concept behind, so Ansible would fit into the infrastructure as code concept, and with Ansible, you could build basically automation so that when you're deploying a Flask app that serves out a machine learning model, it would be programmatic. So I think in general, you need to have infrastructure as code. And I guess a couple other questions are: do you fill pull request or push review? I personally like GitHub pull requests. I think that's probably the best way that I like handling code reviews. And then what is dev security operations? I think that these words that are now emerging, I think DevOps was popular, and so now everything's ops now. We have like GitOps, dev security ops, ML ops. I think you could just go to the root, which is anytime you look at something that's got ops in it, it means that it's automated. I think that's the big thing, is that you have, and so what dev security operations would mean would be that you're automating securely building things, right? So potentially you bake into your system that you do principle of least privilege, and you bake in that you are scanning your code automatically for errors, or you're scanning containers. So it's just a way of automating a practice. Another question that is coming in here is, should I automate? Should I replace Git instead of TFVC as my version control system? I actually don't know what TFVC is, so I'm less I'm less confident in answering, but I would say probably it's hard to blame it for many things. It's really a pretty wide standard now. So the fact that you could use modern hosting tools like GitHub, I think is probably one advantage to using a Git-based system. Okay, great questions. I'm going to move on to part 2 here. And so we're going to get into automating the text and file system. And so we'll go through reading, writing, text files, CSV files, YAML files, use pathlib. So this is all stuff that's, we'll call it bread and butter DevOps stuff that I think will be really handy to go through and make sure that everybody's got some experience with. Okay, so let's go over to this notebook again and we're going to cover basically not only the automating text and file system, but I also just briefly wanted to cover functions, which goes to the question that someone asked earlier: is how much do you need to know about Python in particular? I think this might be a key section here to be aware of that could help you with that, and then we'll get into the text and file system. So functions in Python and lazy expressions are really an important thing to know about, because it's really the foundation for building DevOps tools or building cloud computing tools. And in particular, here's the simplest function. This is a function that just returns a string. It's not that useful though, because a variable does the same thing. So really, you wouldn't want to use a function like that. By the way, you can actually make a function even more simple by just putting pass, and then that doesn't do much. So this is more of just an example of how simple you can make a function, although they're not that useful. You can go and document a function though, and in this case, if I added a triple quote to it, this will actually add something called a docstring. And a docstring, I can get at it inside of Jupyter by putting the question mark. And look, you can see that it puts this question mark inside of there. So a docstring is a pretty useful thing to add on a function. And if you're ever looking for documentation in Python, you can think of either using the dot under doc to print it out, or you can also do the question mark in Jupyter. Now, to build functions, this is really the key takeaway, is that you pass something in and you do some work. So in this function, I say, I want to practice, X number of times per day. There we go. And then I can actually go through here and build this out. The key takeaway though is that if I want to put multiple things inside of here and do more work, I would have to order it specifically. So in this case, I would say, I like to practice technique times a day for duration. So if I put in, I like to practice the piano 3 times a day for 45 minutes, I would have to make sure that I first put 3, so that it would correspond to that. Piano would correspond to that. And then 45 minutes, it would correspond to that. But the problem here is that because I'm able to guess on, I'm hoping that the order will be the same, it's easy to make a mistake. So if I then swap the order around, we've got a problem. So in a function with Python, I would recommend this key value approach instead. So here's a function where I say times 2, technique, Python, duration, and this will allow you to basically print out, say I like to practice Python 2 times a day for 60 minutes. And I also can use it in any way that I want. I can swap the order. So a Python function that has key value pairs is probably the most robust one to build. You also can do args and keyword args. So here's an example where I could go through and arbitrarily take keyword arguments and then print them out. So you can see here, I can actually just pass in as many different kinds of key value pairs as I want. An even easier way to handle that is I could define a dictionary, which would be all my key value pairs, and I could pass them in just like this. Now, a function, one of the things you can do with it that's pretty neat is that you can actually have a function that passes things into another function. So in this function right here, what I do is I say, if this technique is inside of these attacks, so here's the technique, show me what the technique is, otherwise return unknown. So if I pass in something, you can see it works. But if I pass in a technique it doesn't know about, it says unknown. So I could take that function and actually pass that function into another function that actually uses it. And so in this case, it says for every attack that's in this list up here, pass it into this function that isn't inside of here. It's I'm assuming someone will give it to me, and then I can use both of them at the same time. So I can extend the functionality of the other function by making a new function that uses it. So this is a neat approach to building things in Python, and it works really well with DevOps style programming. Another thing you can do that it's fairly advanced, but it's more of a stretch your brain example, is that you can have functions that have functions inside of them. And this particular example is a function that has some counters. So these are variables that are only associated with the, basically inside of this function. And so this inner function, by using non-local, it can kind of hop up one level and mutate this variable. And so what I do here is I basically keep track of who's attacking. So it's almost like a function that you would use for a video game. And then it increments that count. So this could be used in like a karate game or something. So you would go through here and say, fight, load it up. I can see that it's returning back. The outer function returns an inner function. And then if I call it, it says attack 1. If I call it again, we can say it's got lower body attack, upper body attack, right? So basically it's going to keep the state permanently. So there's some neat little things you can do with functions in Python. Another thing you can do is you can run partial functions. So if I go here and I say, this is just a regular function that has 2 arguments, I can say only call it with 1 first. And now if I notice the type, it's partial. And then if I want to execute the last part, then it finally triggers. So this could be useful in an automation workflow, for example, to maybe build up a bunch of stuff and then at the very end, you then execute it. And if you want to run the same function, it didn't change it. One other thing that I'll show really briefly here is that with functions, you can also build generators. And this is really handy for dealing with infinite data or infinite network traffic. In this one, notice that I say while true, and I randomly select something from this dictionary, and then I yield out the result. And so what I can do is I can say, give me this generator, and I can basically consume it forever. And it'll always give me back new results forever. And so this approach of yielding is a great way to deal with a huge data stream, because you're only consuming one thing at a time, and it's very memory efficient. So functions are very powerful, as you can see, and one of the things you can do with it as well is you can wrap other functions. And one way to understand a decorator is to write them yourself. And this is a really common pattern for many things in Python. And here's an example where I have a outer function, which is a randomized speed attack. And then inside of it, I have this inner function. And what I do is I can then intercept a function and then add a sleep to it. So if I then put this randomized speed attack decorator on the other infinite generator, what will happen, let me just execute it first. What will happen is that it will just change the behavior. So if I run this, you can see it does the same thing it did before, but it adds these random sleeps. So why would you even care about building something like this? Well, one thing that would be neat is imagine you could build your own randomized sleep function to test out maybe do some chaos testing or do some kind of stress testing for your network to make sure that it's able to run things in a way that would under load or under weird conditions still perform properly. Also, there's a timing decorator. So in this particular example, I could actually go through and build my own decorator. And by using the functools wraps method here, what this does is it actually will preserve the function that you're wrapping the name of it. And what I do is I basically figure out how long it takes to execute a function. And then also I capture the name of the function, the arguments, the keyword arguments. So this is basically like an instrumentation tool. And so if I then run this, you can see here that at the end it says it took 0.0008 seconds, and it shows me what was passed in. So this is another one that would be a fun one to play around with. If you want to learn how to write a decorator, I would say just tweak this code a little bit and play around with it. It's a great way to learn decorators. You can also make a class behave like a function as well. So if you add under call here, this will actually make it act like a function. And so you can basically call it like it's a function. So one of the reasons why people do this in general is that you can do programming that a function-based workflow works better at. And in particular, you'll see this in data science a lot, is you say import pandas as PD, and you print out a data frame. But to do anything with it, I need to actually run some code on all 150 rows. And so how would I do this? What I could do is I could run apply, and apply is a way of basically calling the same function 150 times. And all I do is just do dot apply. So it's a really clean way to avoid building for loops, which is not the way to do things in Python. Look, if I, in pandas at least, in this case I can see I added a new column, and I could even go further, and I could add a function here that multiplies every single row value by 100, right? So if I go here and I say apply, now it's using the custom function that I built. And if you want to uncomment this, you can see that it's being called every single time. So a function is really, I think in the world we live in today, probably the most important thing to master in Python. So let's kind of scroll down here. And so, this is something on your own maybe to play around with, is that you can, maybe write a function that returns infinite values, and then go through and play around with how to write generators. Okay, so let's also do one other thing, which is I think we had talked about this earlier, but this is an exercise you could try as well, which is capture the output of this shell command, and you can do that with an slist grep. And the way to do that would be to, first again capture it, maybe assign it to a variable, and then you can just grep something like, let me find a Python file. In this case, there is no Python file, and so maybe you would want to grep for, something else that lives inside of here, like maybe even it would be the word data. Like what happens if I say data, and you can see that now it's able to find and grep it. So let's keep moving here and get to the file system now. So DevOps people being able to write and read to a file system and YAML files is critical. And so this is probably maybe one of the most important sections to be a master on. Let's just go through briefly on writing a file in Python. In particular, in Python, you'll see that you can open a file and make it writable and just write line by line, right? That's one way to do it, and then manually close the file. And then if I run cat, I can see what was inside of it. The problem with this approach is that it's easy to forget to close the file. So there's a common error. So instead, you also could, even if I clean it up and I, make it in a loop and I write it, I still have that same problem of needing to manually close the file. So what's a better approach? Well, a better approach would be to use this thing called context. And look how simple it is. I say with open, and what it does is it automatically knows that when I'm done writing to the file, like when this block is finished, it'll automatically save the file for me. So this is definitely a much cleaner way to write to a file in Python, is to use context. And I typically only use this now because I just don't like writing extra code. Reading a file is the same. So I can go through here and I can say, open up a file, read the lines out, and then print them out. But I also have to remember to close it. But if you use context, it's actually much simpler because it'll also automatically close it after you've read it. So in general, the main takeaway is don't work as hard. Use the context to read and write in Python. There are other formats, though, to be aware of. And in particular, there's a Python dictionary to pickle. And so this is one of them that you can be aware of, is that in Python, you can go through and create a dictionary and then say import pickle, and you can do pickle.dump. And what happens is that you can save this Python data structure to disk. And this is really handy, especially because you can not have to worry about, understanding the connection string to a database or whatever. If you just need to quickly save something, this is a great way to save it, and it's a native Python data structure. The problem, though, with a pickle, the downside to it is that it's not human readable. So the approach that solves that is you could serialize it to JSON format. So in this case, if I say import JSON and I say with open data.json, and then I cat this out here and I say with open data.json, you can see I can read and write to JSON, and it's fairly human readable. And what's also nice about JSON is that I can send it to an API. Most APIs understand JSON. So you kind of get several problems solved at the same time by using JSON as a format. It's easy to use it to communicate with an API. It's human readable, and it saves the data. There's another format that's emerging, which is JSON and YAML are highly related. It's just another form of JSON, essentially. And if I say import YAML, I can use the built-in Python YAML functionality that it makes a kind of a slightly simplified YAML file. And here's an example of that. And if I want to load it, this is actually a YAML file that I can actually load data back and forth in a YAML file. So you'll see this a lot with build servers that most of them use YAML. So it's not a bad skill to have, which is to programmatically read and programmatically write YAML files in Python. So if you wanted to go through this exercise here, this would be a good thing to play around with, is go into this reading and writing a YAML file, open it up, and then take a look at how it would work. And notice I say safe dump so that it safely serializes the data as well to prevent security holes. And here's just some questions here about what's the difference between pickle and JSON. They're basically the same thing. It's true, just one is unreadable. Now let's move on to the next section here, which is managing files and directories using os.path and pathlib. So this is a really common thing as well, which is that you will need to manipulate the data on a file system. And one thing you can do is you can actually say, for example, use this pathlib library, which is pretty new. I think it may be under some changes in Python 3.7. I think we're up to Python 3.9 now, but basically pathlib has got a lot of really interesting features. Like, for example, look at this. Depending on the script you're writing, you may want to make this false. You can say, look, here's his path, and I want you to make the directories automatically. So it's essentially like make dir-p as a shell command. And then you can see here that it was able to actually work on it. Now, if I go through here and I say import pathlib, I also can create mini paths and then see, do these paths exist? In this case, it didn't create the path, so they don't exist. But in this other one, the sumder, I created it up here. It exists. So you also can use it for like checking, right? So if you wanted to write some kind of, automation check that went through and verified whether some path existed, or, maybe like a health check, this would be a great tool to build a health check with. Another thing you can do with the pathlib library is you can also write text out. So in this example here, we were able to, write some text out, also print this out. And then if I notice this, it says use pathlib to rename files. What's neat about this is that the pathlib library itself, I can actually go through and open up a file, write it. I can rename a file, right? So basically, this pathlib is almost like a one-stop shop to build a lot of different things that you would need to do in a file system. It can rename things, it can move things, it can, check for paths, and that's actually, I think, one of the neat things about this pathlib library. If you haven't used it, there's another similar functionality, which is FN match. So FN match, what this does is it allows you to basically look for matches for a keyword, right? So you can go through here and say, I want to look for all the files that have the word CSV, and then it would go through and it would print it out. Another functionality in Python that's actually a really cool functionality that isn't that widely known is you can create your own backup scripts that are very comprehensive with just a line of code. So if you use from shutil import make archive, what you can do is you can say make an archive that's a gztar archive. So create a tar and gzipped archive in one line of code, and it will just bundle up a directory and then zip it up for you. You could also do the same thing with the zip archive here, and then you could basically print out what's inside of there. So in this case, let's move on to walking directory trees. This is something that I've done quite a bit in scripts that I've written, is that I need to find something on a file system, and the only way to do this is to walk it and just step by step kind of look for things. And so the core concept here is that you basically say, from os.path, import join and get size. So I'd say for root dirs files in os.walk, and then I would go through here and print out step by step what happens. So how do we do this ourselves? In this example, I'm going to import the OS, and then I'm going to say from os.path import join and get size. And when you do os.walk on a directory, it gives you back three things. It gives you back the root, the directories that are available, on the files. And so if I write this, I can say for name in files, full path is equal to join root name, and I can say full path to files is this, and I can actually print out all of the paths that I find along the way. So this is a neat technique to look for things to back up, or look for problems on a file system, or anytime you need to crawl the file system, you can use this os.walk method. Another thing that's handy as well that comes up is, what about getting information specifically on files and directories, like what's the user permission? Well, what I can do is I can say os.stat location, and we can say result is equal to the group ID, right? So I could go through and I could say, let me crawl the file system and look for all the group IDs that match a certain group ID, right? And to make sure that things aren't corrupted. Or if I want to look at the size of a file, I could also use stat. So stat is a really handy library to run. Another one that you could use as well is subprocess.run. And you could either use use it in its own kind of default method, which is safe, or you can use this thing called shlex or shell lex. And what this does, if you use shell lex, is allows you to create a much more complex script. So, for example, if I want to sanitize the input, it will actually make it so that by sanitizing the input, I don't have to worry about somebody passing in code that would be malicious, right? And so anytime a shell command is wrapped up into a script, this is a huge security hole that has to be addressed. And by using shlex, it will actually sanitize it so that it won't accept inputs that could lead to problems, right? Like where someone puts like a rm-rf and they slip it into a script that you're accepting input from. Another one that we can talk about is a health check. So this is a really common problem if you wanted to build some monitoring scripts, is that if you're, let's say you're creating containers or you're creating virtual machines or deploying software somewhere, one thing you might want to do as a post-deployment process is actually check into a UID and see that the right UID has been created, right? So in this case, this would be subprocess.popen, touch a file, and then make sure that it's actually going to set the permissions correctly. And this could be something that could fail the build, right? Or fail the deployment, and then you would need to fix your deployment process. Another one here is finding files, duplicates, globbing, and patterns. So in this particular example, one of the things that we could do is say import subprocess, and I could actually find, using the find command, certain directories. So this is also another thing that's neat about Python, is you can wrap up really useful tools and just put them into a subprocess module. And that's also a great way to use Python. In this particular example here, this I'm going to touch a CSV file and also touch a bar, this text file. And then if I run glob, I can actually look for that particular pattern. So that's another thing that's pretty cool about the glob method here, is if you just want to really quick and dirty look for a certain pattern in a directory, glob is a great way to do it. Is just say glob.glob, and then it'll return back all the matches. So how would we use this? Well, one of the ways that we could use this is going to this path here and saying results is equal to glob.glob, right? And then if I print this out, it'll show me all of the different matches, right? Because it looked inside the path that I gave it, and it found all these CSV files. And here we go. Here's another one. I can find all the JSON files as well. So in a nutshell, that's probably a good spot to take maybe a quick 5-minute break. Okay, so we should be back from break, and I'm going to answer a couple of these questions that have popped in here. One question is, what is the difference between a pickle and a YAML file? So let's just stay with the screen share approach here, and I'll just, again, maybe whiteboard that out. Here we go. So what is the difference between a pickle and a YAML file? Good question. So the key thing with a pickle or a YAML file is that a pickle would be native Python format, right? So basically with this, you're taking a Python dictionary or some other data structure, and you're directly writing it to disk. And the downside of this, if there is a downside, would be that you can't read it, so it's unreadable. The upside of it, though, is that it's pretty straightforward. You just say, here's my Python dictionary, put it to disk. A YAML file is a JSON-related file. So in this example, you could write something out that is essentially JSON but a simpler format. And also YAML files are human readable, right? So you can look at this YAML file and you can see very easily, what's inside of that particular file. And so that's really the key differences. One's native Python, the other one is human readable, and also a YAML file is a simple structure, right? It's fairly straightforward to look at. So another question, I guess, about the pickle. With regard to pickle, if you accept one from a source, isn't there a threat that you can blow up? Yeah, I think one thing about any file that you can execute is that, in theory, there's some kind of security hole that you could introduce into your system. Now, if you created it and you're able to verify that serialized file, that's a little bit different. But yeah, if you are just grabbing a file from somewhere else and executing it, in theory, there could be some security implications for that. Let's see here. And let me go to the next question, and we'll throw that to the slide area. So permit root login, yes or no from remote servers. If it's set to yes, then the display as enabled, or yes, then it's no display enabled. If commented, then display as configured. I don't know the question there. Maybe I'll just come back to that one. I'm not sure what that one means. And so one other question is, can you give some find string options? So one of the things that you can do with Python that is pretty handy is regular expressions, right? So that's one way that you could handle doing string processing, is to actually write a regular expression that is able to go through and find different patterns in strings. So I think that's probably the cleanest way to handle complex strings. And another question is a good question here is, what does the wraps method do here? So the wraps method, the only reason if you're going to write your own decorator, so we'll just say Python decorator, the wraps method will preserve the function that's getting wrapped. So if you say from functools wrap, basically, if I'm writing a timing function or something like that, is this outer decorator, which we'll just call this timer or something like that, if you don't use wraps, it'll actually discard the function's name here, so it'll make it garbled. So like we'll just say run or something like that, and so by return something. So basically, if I use wraps inside of this decorator, this name here will appear, and so then I can do something with it. I can say, here's the function that ran, and then here's the arguments that are passed in. So it's basically, that's the only thing it does is it preserves the function's name that you're wrapping. Another question here is, can you explain the args and keyword args? Yeah, so let's just do that real quick. So the key difference with args and keyword args, if I say, def run, and this one does asterisk args, or if I say def run and this one does asterisk args, all this means is that it can take an unlimited amount of arguments. That's probably the simplest way to explain it, or unlimited keyword arguments. So if you put in that into a function, you can pass anything you want into it. So you could call it with, for example, run, and you could pass in the integer 1, or you could run it and you could pass in run and you could pass in 1 and 2, or you could call it and you could pass in with run, you could pass in 1, 2, 3, 10, you could pass in whatever you want. So that's all it means, is that as long as, inside the logic, you have to be able to account for that, like loop over it or something. Same with keyword arguments, you can do the same thing. You could say def run, and then you could pass in, x is equal to 1. But you also could run it and you could say def run, and then you could say x is equal to 1, y is equal to 2, right? The only thing you can't do is have the same keyword argument multiple times. You have to have different keyword arguments. So another question here, good question, is what about a test? How to use decorators and how to do unit test decorator. I think the when to use decorator. So let's just say Python decorators here. The key thing about a decorator is that the main reason to use a decorator is that you want to augment the performance of something, or augment the behavior. We'll say that. We want to augment the behavior. And so when do you see people use a Python decorator? A good example, one of the most prolific open source authors right now is the person that wrote Flask and Click. And so if we take those two frameworks, Flask, and then we also take Click, Flask basically takes a decorator and it turns the decorator into a route in a web app. So if I had a web app that's let's say it's running, let's do this. It runs HTTP, some URL like run.com or something like that. And then if I wanted to add a route to it, I could run API. And so then in my decorator, I would just say inside of it, I would add inside this decorator, API. And then inside there would be a function, and the function would be the logic for like my API, and then I would run it. So basically, this is augmenting the behavior of a function and making it appear as a route. Now, in a command line tool, it does the same thing. So if I wanted to build a command line tool, I could have some logic that added a number, and we'll get into this actually in a second. Is let's say I have a function that is like adds 2 numbers, and this returns back x plus 1 or x plus y. If I want to make that into a command line tool, I would just put inside of here command, and then it would turn it into a command line tool, so that when I run it, it would be CLI.py, and then I could do -- add, and then it would add in that behavior. So that's where really you get the best bang for your buck with a decorator in Python, would be to kind of tweak the behavior of something. So make it into a web application, make it into a command line tool. Other things that you can do as well with decorators, you can build timers. so you could time your code. You could also instrument your code, so you could, look for, different things that you're instrumenting. I've seen it also used for high performance computing. You can tell it to, a function to run on a GPU. That's what they do in Numba, for example, does that. So basically, it just takes something and just kind of adds a little. It's like you're sprinkling some extra power onto something and making it do more work. Good question. And then I guess for testing, I think probably I would just use PyTest itself, which has testing decorators, and I think that's a great way to do testing with decorators. Okay, good questions here. I'm going to go to section 3, which is we can just maybe do a quick poll here on everybody's experience with Visual Studio Code in a second, and then also we'll get into writing command line tools. So let me first ask that question here is, what is everybody's experience with Visual Studio Code? Would you say, not familiar at all, somewhat familiar, or, maybe very familiar? And then as well, after we ask that question, I would be curious about, how everybody feels about command line tools as well. So we'll give everybody a few seconds to go through this. Okay, so looks like many people are not that familiar there, but there's also some that are familiar with VS Code. So I wanted to talk about that a little bit. That's a great tool to use for Python. And then also another one that would be a good question to ask as well is, what is your experience with using PyLint? And that's another question that I wanted to just get kind of a pulse check on PyLint and PyTest. And the reason I ask these two tools is that in my experience, they're actually probably the top two tools that I use in every project, because they're a good way of ensuring code quality. And I think somebody else is asking, Visual Studio Code versus PyCharm. I think they're both good. I think that VS Code, if I had to recommend though, the one thing that's an advantage over Visual Studio Code is it's free. And then the other thing is that it works on all platforms, which is also an advantage. I think PyCharm works on all platforms as well. But the thing about Visual Studio Code is that because it's actively being developed by Microsoft, and it's so widely adopted, it does feel like it's really where the energy is headed in terms of tools for building Python is in the Visual Studio Code section. Although that's a good thing to know about if PyCharm has good Terraform support. That's a good point. Okay, so PyLint here looks like many people are not familiar at all with it, and PyTest. So good. So these are some good baselines for me to get into. So what I'm going to do next here is walk you through how to set up a project with Visual Studio Code and also pip, and then we'll get into command line tools and sysargv. And so what I can do here is just share my screen, share a Visual Studio Code screen. So I'm gonna go ahead and do that in a second here. So let me just change my code to Visual Studio Code, and I'm gonna just grab this thing as well, this repo. So So I'm going to just change the screen sharing here and pop into a different window. Okay, so the window that I'm going to share here is going to be Visual Studio Code, and I'm just going to kind of talk through this real quick. So Visual Studio Code is pretty neat because again, it's got this great integration with Microsoft, right? So Microsoft has been, actively developing it, and there's all kinds of nice features when you're dealing with Visual Studio Code. And in particular, here's this repo here that I've got a command line tool built into. So when I'm first starting with Visual Studio Code, what I would actually do is actually verify that I have a virtual environment set up. And so how would I do this? Well, one of the ways I would do this is look at this link here that says Python, and it'll show me the actual interpreter that I'm using. So if I don't have a virtual environment loaded, that's typically one of the first things that I would do. And so what I can do is actually open up a terminal at the bottom here, and you can see I'm in this repo, which is a checkout of the repo that I shared earlier. And so if I just say get status, we can see that, okay, I've got an untracked file inside of here. And if I do a ls-la, we can see that there's not a lot of stuff in this project, right? This Python DevOps course. But if I do a get pull, let me just add this file in here. Just say adding local file, and then get pull. So we can see that there was a conflict, and I'll just fix this conflict, which should be easy to fix. Okay, that looks like I can fix that. All right, so I'm going to just sync this up with the main repo here, and then I'll explain what I'm doing. So if I just say get status, we can add hello and fix this, fixing conflict. Okay, so this should be a repo that you have access to, and you can use yourself. It's in the course resources. So the first thing that I would do in a project like this would be that I would make sure that I'm using a virtual environment. And in this case, if I say get remote -v, you can see that the name of the repo is called Python DevOps course. So I like to create a virtual environment that is the same name as the course or the checkout. So I'm going to go ahead and do that. I'm going to say Python 3, maybe make this a little bit bigger, Python 3 -m, venv, tilde/ and then I would say a dot. And why I like this pattern is that it creates a virtual environment in a directory that's inside of my home directory and puts a dot so that it's invisible. So basically the reason for this is that now I don't have to worry about accidentally checking in this virtual environment inside of my source control, and I also don't have to remember what it's called because it's just going to be called the same name as my course. And then to source it, I would go through here and say tilde, the name of the virtual environment, and then do bin activate like this. And now you can see that it changes, right? I can go here and I've got this. If you're not familiar with the virtual environments, the whole point for creating virtual environments is so that you don't have to worry about weird conflicts from one project to another. And in general, it just makes it so that you have a much less likely chance of having your project blow up, right? I mean, that's really one of the key learnings, is that it really stops your project from having problems. So once I've got this set up, the first thing that I would typically do would be to also go to this Python interpreter in here and just find my virtual environment here, and we can just say tilde slash dot Python DevOps course. And let's see if I can find that. It should be able to find this virtual environment here, which I guess I could just do this. I could just say ls-l tilde slash dot Python DevOps course, then Python, like that, right? So we can verify that that's the Python path. So I should be able to just throw this in there, and it should just use that. I don't know why it's having problems using this virtual environment, but for now it's not critical. The key takeaway is that if I want to run my code, I can run it in this virtual environment. It might be just because I need to wake it back up again and tell it to use this virtual environment. And actually, I'll just show you how I would do this. One thing I can do is I can actually just open it up again by sourcing it in another shell. This is how I typically do it, and then it'll take that virtual environment. So I'm gonna go ahead and do that. I'm gonna say Python DevOps course in another shell you can't see, and then I'm gonna open up Visual Studio Code again, and then it should basically open it up correctly. Let's see if that works. So I'm gonna close this temporarily, open up Visual Studio Code again, reshare it, and it should have found that right interpreter. Yeah, there we go. So I just needed to wake it back up again. And let me just double check that sharing works here. So one of the things that you can do that I changed here is that in your terminal, if you source the virtual environment and then say code space dot, it'll automatically find your virtual environment. So you can see here that, look, it says current and it says Python DevOps course, right? So it found the correct virtual environment. Again, it's not necessarily that big of a deal, other than the syntax highlighting will not bug you. And then in the terminal, if I want to execute things, again, I'll just run this command, right? And then I get both. So I get the correct virtual environment inside of Visual Studio Code, and I also get it in my terminal. And then the first thing I would do in a typical DevOps project is look at this makefile here. And I like to create a makefile that goes through and has key things set up. So here's an installation right here. So this is actually a way to install my software automatically. So if I go to requirements, you can see I have a PyLint, I have Click, I have PyTest, and I have PyTest Cov inside of here. So in this particular example, how would I run this or install my software? I would just type in make install like this. And then what would happen is it would go through and just run this command. So the reason I like makefiles is it's an easy way to basically build out a structure for a project and not have to remember things, right? Like it's a great way to essentially have tons of commands that are useful, and then it's really easy. I just say make install, and I know that I can use it to install packages. Now, if I want to build a command line tool in Click, that might be the next thing to do here. Let's take a look at this structure here and see how we could easily build this. So I could say import Click. Here's an example. And I could say click.command here. And I could say click.option and then say -- phrase and then do enter a phrase right here. And what this would do is it will, and this goes back to a question earlier about what's the point of a decorator, is by adding these decorators on top, it converts a really simple function into a command line tool. And so what this will do is it'll build out something that says phrase in a command line tool. And we also could even add help to it as well. So I could go through here and say, maybe wrap this line to make it a little bit more palatable and say, pass in a phrase to tokenize, like, i.e. the whale is large. Okay, and then this is, I could even put documentation as here, and this will show up in documentation. This is a command line tool that tokenizes things. So the only other thing that I need to do that's kind of irritating is that PyLint will actually put this no value for parameter. This is something where you have to tell PyLint inside of here to ignore this, and so you can safely ignore this for now. But basically, I'm going to go ahead and run this now. If I say, Python hello click, and then I do -- help, you'll see that I can actually get a nice help menu that appears automatically that is exactly what's inside of here, just like this. And then if I want to actually run help on phrase, or it also shows the phrase itself, it actually gives me more information. So just at a few lines of code, you can build some really powerful things. So let's go ahead and test out this tool. So we'll go through here and we'll say tokenize, or what phrase I mean. And for phrase, I'll put in this, I'll just say put it in maybe in quotes here and say, the whale is large. There we go. And notice here that it says the whale is large, right? It gives me back a tokenized phrase, right? So it's kind of an intentionally simple tool. And what's neat about this is that I can start to build more and more complex things by then integrating linting, and I can also integrate testing. So how would I do this? The first thing I would do is go to my makefile here and double check that I have a lint set up. And in this case, I think we're running this hello click tool. So I'm going to go ahead and lint this out. So I'm going to go through here and go ahead and run this. Now I think it will fail because of the fact that I have the issue with it's giving us a spurious error, which says no value for argument phrase. And you'll get this. This is not that common, but occasionally when you're using PyLint, it's not smart enough to realize that's actually something that the Click framework does, because Click has all kinds of fancy tricks inside of it. So to get around this, what I can do is actually add that to the makefile, and I can just say disable this. Like I can say, look, that's not something I want to check for. It's a little bit too noisy. And if I run make lint again, now everything works. And so the reason for doing linting, and especially doing it like this, is that later when I get into the build server, I'll show you why this is actually important. So if we go to the command line tool here, the reason for linting is that if I put a bad piece of code like that inside of here, I would want it to give me an error. And so I can actually test this out and say make lint, and it says, uh-oh, there's a problem, inside this code, and it will tell me exactly the line and also even the character where the error is. And so this is really handy in that I can actually use it as a quality control system. And so this would go into my continuous integration process when I set this up later. So we've got linting set up. Well, what's the next thing to set up for a command line tool would be to do tests as well. So how would we do this? What I'm going to do is I'm going to write a test called test hello click. And in order to do that, though, I think I'm going to merge these words together. I'm going to change the name of this. So I'm going to say get mv hello click, and I'm going to just change it to hello click. And the reason for this is so that I can import it in a test. And that can be a problem, is that Python, when you import it, doesn't like the separator there. So next up, I'm going to create a test file. So I'm going to say touch, and then I'll say test underscore hello click, like that. And from here, it's pretty straightforward to test. I would just say import pytest. And I can look at a previous test here. I can say from click testing, basically import this test runner. And then also I could just do something like this. So I'm just going to basically copy this one as a template and put this into there. So I can go here and then see this test. So I'm going to change this to the name of the thing I'm importing, which is the hello click. And then I'm also going to say from hello click. Notice there that it pops up. This is one of the great things about Visual Studio Code, is it has all kinds of great, syntax highlighting and auto formatting and everything. Is I'll just need to look into this file here and import this function, which is tokenize. So I'm going to go back here and then say from hello click import tokenize. And then what I'll need to do is pass that into invoke, right? And what this invoke will do is it'll basically, it's a functional test. It invokes it as it would be invoked from a command line tool, which is pretty handy. If I say tokenize, now I just need to pass in what it would actually need. So we know that it accepts. I can actually even take the last command that I ran, which is make, where is this thing? Well, I'll just look in this code here. I'll just say, I want to say the whale is large. There we go. Let's check that out. So I'm going to go through here and I'm going to say invoke it with the word phrase. So invoke it with phrase. And then also just pass in the phrase. So in this case, I'll just put in a string and we'll say the whale is large. Now we know that the whale is large will be tokenized and it will come up with a specific data structure. And so we could even just do that, right? I could just run it real quick and say Python click or Python hello click, and then do dash phrase. The whale is large, and then I could actually just put this inside as a test and just say assert that this output is in the result and that the command line tool functions correctly. So if I go through here and I do this, I can actually go and say Python and then or I can actually run make test. So I'm going to go to the make file here and I'm going to say Python -m pytest. So use the pytest framework. Tell it to do coverage report. So in this case, this would be coverage of hello click. And then we can say test hello click. There we go. That looks good. Looks like that's working correctly. And then what's great about this is that I can from here go ahead and do a test. So I can just say make test. Now notice that there's some issues in that it wasn't able to pass the test. It says in string requires string. So I think that this would be one of the things to check, is that I can just maybe make this a little bit better. That too brittle of a test. I can just say assert that. How about this? Assert whale is in output, right? Because it's not a literal list. So we'll just assert that this is in there, and then I run it again. There we go. So basically we have a test that tests our command line tool here, and we also have linting. And so now what's great about this is that it would be fairly straightforward for me to actually go through and kind of build out some kind of a structure here in a continuous integration server, because I have linting and testing. So in the make file here, notice how I have an all statement, and this is probably the steps that I would want to run locally and then also in a build server. So if I say, for example, make all, this will go through here and say, no module named hello click. Oh, because I want to get rid of that. I don't want to lint that other file. I want to lint this file. So let's go through and run this. So it tries to install all the software, passes a lint, passes a test. And so we're actually at a great spot now to do a lot of really powerful things by actually using this install, test, and lint setup. So this is really the foundation for continuous integration. So we have local continuous integration running that command, but now let's move it to the next level, and then let's hook up GitHub Actions. So what I'm going to do is I'm going to switch gears here, and I'm going to add the test hello here. So we'll say git add test hello, and then say git add makefile, and then git add hello click, like this, and then I'll go ahead and say commit. So adding structure to project, just like that. Perfect. So now that I've got that pushed, what I'm going to do is I'm going to shift gears here, and I'm going to go back to a web browser so that we can set up GitHub Actions. And I'm also going to set up a cloud-based development environment. So we got the local Visual Studio Code. There's a lot to like about it. As you can see, there's tons of cool features and great integration. But now that we've got that set up, let's shift gears here and both go to GitHub Actions and then also in AWS Cloud 9 environment. So to do that, I'll just change what I'm sharing here to those environments. So I'm going to change this here and share my web browser again. And in this course, notice that it's got that new code, right, that I just added. Everything's here, but I want the build server itself to do a bunch of fancy stuff for me. So in order to do this, what I'm going to do is I'm going to look at another project that I have set up, and this project is a PyTest. I think I have it's called PyTest GitHub Actions. And let's go to here, go to PyTest GitHub Actions. And I'm just going to tweak this. And this project has a built-in GitHub Actions workflow like this. And so if we look at what this does, is notice the structure is I have the ability to run on Ubuntu. I can tell it what version of Python to run. And then I also can do certain steps like lint it, test it, format the code here. So in order to do this, what I will set up is a cloud-based development environment next, and then also set up GitHub Actions. So I'm going to go to a new environment called Cloud9. And AWS Cloud9 is pretty neat because it gives you the ability to do a cloud-based dev workflow. And a lot of times I would probably, if I'm starting to build things in the cloud, I would maybe shift into the cloud-based environment. I mean, I use both, but what I like about Cloud9 is that it's pretty easy to get running and build stuff. So the first thing that I would do would be I would create an environment, and we'll call this DevOps environment, and just say, or let's just make it simpler. We'll say DevOps env. And this is for building a DevOps project. And I can say next steps. And then I would just leave the defaults here, which are, create a new instance, leave it free tier, all this stuff. Use Amazon Linux. Although this is actually kind of neat. Amazon Linux 2. Sure, I like that. Amazon Linux 2. And also, it'll automatically time out after 30 minutes. So it's pretty cost effective. All right, we'll create this environment. This will take just a few seconds to create this. So when you're using the Cloud9 environments, the first time you set it up, you will need to create a SSH key so that you can interact with the source code. It's just irritating. You always have to do that, but it's the first thing you have to do. You never have to do it again for the particular environment that you're in, but I'll go ahead and do that first, and it'll be pretty easy to set that up. So I'm going to get that teed up. So I'm going to open up another couple of links here. So I'll go back to DevOps course. We'll get that teed up, and then I'll open up one more so that I can look at my SSH key. So I'm going to go to settings here, go to SSH and GPG keys, create a new one, call this DevOps env, and then hopefully this is woken up. Yep, it's about woken up here. And so Cloud9 has some of the same capabilities as Visual Studio Code. So it has all kinds of cool syntax highlighting and everything. But the best thing that it has is deep integration with the AWS cloud platform. And that's why if you're building things for the cloud, this can be a great development environment. So what I'll do here next is create these SSH keys. So I'll say SSH hyphen keygen -t RSA. And then I'll cat this out. So we'll go here and I will cat this out. And then the next thing that I will do is I will just paste this key into the GitHub location. So there we go, paste it in. Perfect. Okay, so now that I've got that set up, I can actually use this for development, and I'll just clone the repo that is the DevOps course repo. Here we go. Clone this, git clone. Awesome. So now that I've got this set up, I'll do the same thing. I'll create a Python virtual environment, and to be lazy, I'll do the same thing. I'll just say Python, actually, let's just see. This is running Amazon Linux 2. I'm curious what version of Python they have. They have 3.7.9. Wow. So they have a pretty new version of Python, which is kind of neat. So I'm going to say Python 3-mvenv, and then again say ~/ Python DevOps course. And then next, I will say source / Python DevOps course bin activate. Perfect. And now that I've activated this, I can actually check out the repo. So I'll just say, git clone and clone that repo. Oh, I already cloned it. So I'll just go into that repo. There we go. Now that I've got this, what's nice about the work that I did earlier is that I can just say make all, and it should just test everything, install everything, and lint everything. So let's go ahead and do that. We'll just say make all. And this is the advantage of being disciplined in first creating a structure for a project and a structure for a command line tool. And now that I've got this set up, there we go, everything works. So pretty clean environment. And also if I go to Cloud9 here and I go to the file that I was working on, you can see it's got similar capabilities, right? It's got syntax highlighting, it's got all the same stuff that Visual Studio Code has, really. So now that I got that set up, I want to get the build server working automatically. And so what I will do is I'm going to copy this GitHub Actions code from another project, and I'm going to put it into my project. And so there's two ways to set it up. One is that you can just click this button and trigger it, or you can also just create a directory called .github workflows and then just put it in there and it'll automatically run GitHub Actions for you. So it's kind of neat in that you can do that. Let's just be lazy and manually do it though. So if I click on Actions, it gives me all these options to test my code. And look, it says get started with GitHub Actions, build, test, and deploy your code. So that's what this is used for. And there's tons of different templates for you. So it gives you examples of how to use, Node apps, ECS, GKE, all kinds of stuff here. There's tons of different examples, Pylint examples, but I already know what I want to build, so I'm just going to do it myself. And then I'll just paste inside of here this my previous example. So we can see it says Python application test with GitHub Actions. In fact, we can even make it more clear and say Python CI steps with GitHub Actions. And then notice that it's testing on Python 3.8, which is pretty cool. So it is able to test this with Python 3.8, and we're going to go through first to install the software. That'll be step 1. Lint the software, step 2, and test the software. Now there's a step here that I don't have yet in my make file, and it will fail the build, which will be a good experiment. Why don't we do that? Why don't we just check this in and say creating initial GitHub Actions workflow. And then we'll fix that. There we go. We'll commit this. As soon as you make the change and it knows that that structure exists, if I click on Actions, the actions will go through here and run this step. And so from here, you can see that it's building, and the workflow is setting up this job and going through kind of step by step and running this code. So there we go. We see it's linted correctly. It's tested correctly. Uh-oh, the format is messed up here. So there is no rule because we didn't make one. So this is one of the reasons why it's so powerful, is that we get this great feedback loop. So I'm going to go back to my project here, and I'm going to do a git pull to get that GitHub Actions file so that we're synced up with the remote repo. And then what I'm going to do is I'm going to add in the format step. So this is something that I like, is that the requirements file, I can add a tool called Python Black, which is a nice formatting tool. And with Python Black, I can actually just now add that to the makefile. So I can add a step here that says format, and then I can say black asterisk.py. So basically all my Python files, I want you to automatically always try to format them to show me if I've got formatting that needs to be fixed. So if I just say make format, or if I say make install, that will install the Python Black library, which looks like it's working. And then I could say make format, and this should format my code. There we go. You can see it changed a lot of files. So what I like about the formatting is, look, it makes it so that it cleans it up and makes it exactly according to the Python standard, the recommended way to write Python code. So it just makes it look a little bit more professional. Great. So I got that working. What I can do is I can say, get status here, add all these back, commit this, and say adding in formatting. There we go. And now the first time you commit code on a new environment, unless you create the config file, you have to actually, or you don't have to, but it's a good idea to fill this out. So I'll go ahead and fill this out, and I'll put in my information. Here we go. And then I will reset the author. Perfect. And this will open up by the default editor at first, which is Nano by default, and then I'll do a git push. Okay, great. So I push this thing, and it will trigger the build again into GitHub Actions. There we go, adds in formatting. So this I think really shows the power of continuous integration, and what continuous integration really is this concept of Kaizen, constantly improve, constantly make it better. And so in this particular example, I'm setting up a job, I'm running the action, I'm setting up Python 3.8, I'm installing the dependencies, and in particular, we can then test with PyTest here, and then clean things up. So everything works. I'm formatting my code automatically. There's nothing left to do. And what I could do as well is that if I go back to actions, the top level here, and click on this link, there's a 3-button menu. I think it's called a hamburger menu. I can say create status badge, and I can copy this, and then I can throw it into this icon. So we can go here, and I can just throw this into there. And now that I've got this set up, I'm able to fully, verify that I've got the continuous integration set up using GitHub Actions. And we were able to do it in 2 different environments. I was able to get it in both Visual Studio Code, and I was also able to do it in AWS Cloud 9. So maybe a couple things that I'll mention about the AWS Cloud 9 environment now that we've got this set up is that the reason why it's potentially a recommended environment is that inside of here, AWS resources, you actually have the ability to directly integrate with many advanced functions of the AWS Cloud. So for example, I can pull in remote Lambda functions. I can actually build Lambda functions myself locally here. So I can create a serverless application. And then another great feature as well that is less talked about is that the AWS command line tools are already pre-installed, and they'll use the correct permissions. So I don't have to put in authentication. It is role-based authentication. So if I want to look at the buckets that I have in my project, and I don't know, do like what would be WC-L, how many buckets do I have? I have 101 buckets, which is too many. I should get rid of some of these buckets. But I can do synchronized files. I can copy back and forth. I even can download data from Cloud9 as well. So this is actually a pretty handy way to kind of copy files. So if I went through here and I said download, right, I could actually download it, and I can also upload, right? So I can also say here I can go file and I can say upload local files. So really convenient tool for working with the cloud, and I think Cloud9 in particular is a really powerful tool for building continuous integration systems and for doing continuous delivery. Okay, so we're back from break now, and I'm going to answer some questions here. There's quite a few. So first question up is, what are the advantages of using a virtual environment? Must it be used? Good question, and let's dig into that. Let me share my screen here, and we'll talk about this a little bit. So it is a common question, you know, why do I have to use this irritating Python virtual environment? And that it's a good question and a good intuition. So why virtual environment? So why virtual env? So the real reason that this is an issue is that the nature of Python itself. So Python is a scripted language, and as a result, it is dependent on importing code dynamically. So basically, if you say import the OS module or import anything, what's going to happen is that it's going to have to crawl the file system, and it's going to look at things like your path variable. And this is where the problems start. I could go on for hours about things I've experienced with this, but because it's dynamically looking at your paths, it can really pick up anything. And so what could happen is that the Python path could contain maybe like a library that's incompatible. It could contain things that were installed by the operating system vendor, like OS X. And so the reason for a virtual environment then is that it's a way of isolating your code to a particular directory, the Python path. And you don't necessarily need to use it. So we'll just say like my library directory. You don't necessarily 100% have to use it. It's just generally a good idea because you don't know what's already been installed on your system. And if you work on more than one project, then you get into these chicken and egg problems. Imagine on OS X, for example, if you didn't use a virtual environment, or some kind of tool similar to that, you could have a version of Flask that's run 1.01 and then another version that's 1.02, and there could be an incompatibility. And then every time you work on a new project, you would have to uninstall the old version of Flask. So really, it's a big pain without a virtual environment. But if you use a virtual environment, it isolates all your code to a particular directory. So basically, it's a way of getting around the fact that Python will just kind of pull in anything from your operating system. So I would recommend it. I think it is a good process. There are competing tools that also can do similar things, like Conda is an example of a tool that does this. There's also, I think it's called like PyEnv is another one. But the concept is the same, is that these tools exist because of the fact that there is a need to isolate to a particular directory. So I would recommend using them. I like virtual environment because of the fact that it's built in now to Python itself. And that should give you a hint, right? If I run Python 3-m virtual environment, it's literally built into Python, and that's how important it is. So I'm more of a conservative Python user in that if Python, they include it in their virtual, either their standard library, then I figure it's good enough for me. Okay, good question. And let's go to next question here. Is Visual Studio Code for Linux or only Mac and Windows? Yeah, it definitely is available for Linux. I've used it on Linux, and that's why I like it, is that I can just install Visual Studio Code on any platform. And it's great because then I can have a similar experience in all those platforms. Next question here is, what is a requirements file, and how do I automatically generate this file? It's a good question. Let's get into that. So what is the Python requirements file? A Python requirements file. It's really a convention more than anything. And why is it there? So the default tool most people use to install packages in Python is called pip. And the pip tool will actually be installed automatically with a virtual environment. So that's a second reason to use virtual environments, is that you actually get the latest version of the Python packaging tool involved in the virtual environment. And so the pip tool, you can just, option A is you could say, pip install, pandas. But the problem with that is you have to keep typing those commands over and over again. If you get, a 10 or 20 versions of software, it becomes cumbersome. And so option B is that pip itself will support a file that you can put a list of packages in. So most people have now settled on this. If I say pip install -r, I can put a name of a file. It doesn't even have to be called requirements.txt. It's just the convention that a lot of people use. It could be anything. For example, you could have a development requirements, a staging requirements, and a production requirements. But basically, you pass in that file name, and then as a result, it will install all of those all at once. So it works really well. It works well with a CI/CD, environment workflow, and that's probably one of the strong advantages of using a requirements file. So it's just a list of, and so how would you create it? For me, I would just touch it. So I would just run the command touch, and then I would do requirements.txt, and then put in what I want inside of there. And in particular, another thing you can do with a requirements file is even pin the packages. So you can also pin specific versions of libraries. And so you may be asking yourself as well, like, why do I care about this? It happens, right, is you have a project that, maybe you haven't touched it. This happens to me all the time, is I haven't looked at a project in 2 years, and I come back to it and I run it and it works fine. And then I say make install and I update the libraries, and then they all break because there's backwards incompatible changes. So if you pin to a specific version, anybody that pulls your project down from GitHub, it'll work because you've tested it and it's specifically pinned to a version that will work. So there's a lot that you can do. There's a lot of problems that requirements.txt solves. Great question. And another question here is, can we add pytest and pylint command to a Docker file to substitute a makefile? You definitely could. I mean, basically a makefile. Let me just. That's a good question. So let's just dig into that question a little bit. So, essentially, it's why makefile, and then could Docker replace? I don't necessarily think it's a one-to-one replacement because there's different tools. And so a makefile is also optional, right? You don't need to have a makefile. You can do anything you want. why do I do a makefile is that I'm lazy. I don't want to type big commands in over and over and over again. It's just easier for me to say, make install. And then inside of there, I've got how to update all the packages. And so it's not a requirement at all. In my opinion, it just makes a project easier because you can put in a bunch of different commands. It's an abstraction, right? It makes it easier to remember what to do. Now, Docker, I don't think it's a direct replacement. I think they're useful, right? You can have a Docker file that you can run things and do things in it. It just depends on what are the different things that you're trying to do. When you're first developing the project, really what the Docker file does is it can create an isolated environment for you, but it may be more of a complementary tool versus a competing tool, right? In my opinion. And so it's very likely you would want to use a Docker file and a Makefile. Or if you, for some reason, don't like Makefile, again, this is just my opinion. I think they make things easier, but you don't have to use it. They're a Docker file. The real advantage of that is that you're isolating the environment and isolating the runtime so that you know exactly when you deploy this software to some other place or you give it to somebody else that you can compare not just the source code, but the execution environment that it runs in. And another question here is, why do we include if under name? Great question. Let's dig into that. So this happens all the time, in a Python project, is why this under name nonsense, right? It's irritating to people that are new to Python, and it's actually has a fairly simple explanation, and the explanation is that there's two forms of running code in Python, right? So we'll say there's two ways to run Python code. The option one is that you can actually import it. So let's say you have a file called lib.py. If you say, and inside that file, let's just say you have a function called foo. We have a def foo, and it just basically returns back the integer 1, return 1. I could say from lib import foo, right? So that what would happen is I can now reuse that code. And so in that case, if also in this lib file, so this is option one, in this lib file, I had that if under name. So we'll just kind of sketch this out here. Basically it would only run this. It would not run this bottom statement. And so that's all this does, is it says, look, only run this if it's executed as a script. And so this makes you able to both import code and run it as a script. So now if I want to run Python lib as a script, underneath here, I could put a function that says basically like print foo or something like this. And then what that would do is it would actually print out the result of this particular function. And so then I could run it the second way, and I could say Python lib.py. So that's all it does. It tells the Python executable or the Python interpreter, if I'm going to import it, don't run this. But if I am going to run it from a script, that actually run this bottom line of code. And virtual environment versus pip env. As I mentioned, for me, I'm at that's a good question. Let's just dig into it. So, virtual environment versus pip env. So this is the way I think this just happens as you get older, is that I've been using Python 20 years plus. And so for me, the way I think about things, again, this is just my opinion, is that if it's built into the standard library, I automatically think it's good, right? There's a reason some really smart people decided to put it in there. And in the case of virtual environment, that's definitely in its favor, right? Is that it's built into the standard library. The second reason I like virtual environment is that it works. I use it almost every day and I have no problems with it. And so I don't necessarily find myself lacking something that it doesn't solve. And then also it's ubiquitous, right? Is that virtual environment is we'll just, instead of ubiquitous, we'll just say everywhere. It's everywhere. Now the pip env seems like a good tool. I've tried it a couple times, but for me in particular, because of these things, is that I already have something that works. I don't have anything to complain about. It's built into the standard library and it's ubiquitous. Like everybody knows what virtual environment is. I find no reason to change. That doesn't mean it's pip env isn't a good tool. I just have no reason to change. Once I find something that works for me and I have no complaints with it, I just typically stay with it. And next question here is which is a pretty interesting and good question. Can we bypass virtual environment with Docker? So virtual env versus Docker. In theory, yes. In practice, it might be slightly harder. So you could do this because in Docker, what Docker does is it will isolate the runtime. But there are a couple gotchas here that are important to consider. So in theory it could basically solve the same problem, but now a question is who made Docker? So in the case of the Docker file itself, the author of the Docker file will also, the problem doesn't go away, right? We have a chicken and egg problem, because if inside of the Docker file you have to do a pip install, where is it going to be installing from? Well, it's going to be installing from the host OS, and the host OS, those same problems still could exist. It could have a vendor specific libraries that accidentally get thrown inside. You could have conflicts. And so I guess the most pure answer is if you're using Docker, you're using somebody else's Docker, yeah, the virtual environment solves no problems. Like, it does nothing to it. But if you're the author of the Docker file, then I think you still would benefit from virtual environment, because again, you want to protect your environment from whatever OS 10 decided to put into into its operating system. It could put some old version of a library that accidentally gets put inside, or you just don't know what's happening unless you isolate things, because of the nature of the Python as a scripting language. Now, the other languages like Go, for example, you can package everything up in an executable and you don't get these problems. But because of Python, I think even in the case of Docker, if you're authoring the Docker, you still would want to use a virtual environment. But if you're using Docker, using somebody else's Docker, they created it for you, yeah, it doesn't solve any problems at all. And another question here is what is setup.py? Okay, let's dig into that. What is setup.py? So setup.py is used when you're doing Python packaging. And so the reason to have a setup.py file, one of the best reasons would be for, let's say you want to build a command line tool, right? And this command line tool does, I don't know, I have one created that analyzes GitHub. So we have one that analyzes GitHub, and then you want to share it with other people. So what you do is you create a setup.py, and in your setup.py, you would create the instructions that tell it how to be packaged for delivery to the Python package repository or PyPy, and then you would run that, and then you would deploy your package to the Python package repository. So Python package repository. So that's probably the simplest explanation of a setup.py file. Is it's a necessary file to do deployment to a package repository, right? And you can even credit your own private Python package repositories as well, but that's the core reason for creating a setup.py. And another question here is, so when do we use object-oriented programming and when to use functional programming? Yeah, it's a good question. So let's do that. Let's talk about OO versus functional. I think it's really the case that, especially in the cloud world and the DevOps world, that most of the time, I would say probably 80% of the time, functional programming is probably the preferred method, and then 20% would be OO. And why? The main reason is, if you're doing cloud computing, it's by its nature a distributed computing problem. And so distributed computing really works well with functional programming because it's really a unit of work, right? And so this unit of work can accept things and then process them and then return things. Also, in a functional environment, you can do data science as well. So data science and machine learning, it really, because you're dealing with things like data frames, and they work by applying functions to columnar data, and also in terms of the simplicity, right? It's much simpler to build functions, and then also microservices work really well with functions. So I would say in most cases for cloud computing, data science, DevOps, just writing functions is really the way to go. Now the question though is, when would you use object-oriented programming? Where are some clear use cases? Well, if you're building a user interface, I think that's a clear use case for UX. So good examples would be Xcode. So if you've ever built a mobile app or played around with Xcode, really object-oriented programming is super helpful because you can reuse code to build UIs. Another UX example would be PyQt, right? So PyQt is massively object-oriented, and it's helpful. It's helpful to have that. So I think that's really the place where I would use object-oriented programming. Another one would be if you're a framework developer, and this really gets into a very specialized use case, but in functional programming, you can use an object, but you don't necessarily have to create the classes that make the objects. A framework developer would be creating the classes that someone would use. So really, I think these are probably the two strong cases for object-oriented programming would be, user experience type things, Xcode, PyQt, and then frameworks. If you're building, pandas yourself or scikit-learn or some, very complex framework, then yeah, there's a lot of value in creating object-oriented programming in your internal code base. But the user of the framework, they may not need to know anything at all about objects in terms of, creating classes. And I think there's a simplicity that you get from not building classes. So personally, I almost never write classes anymore. I just don't find myself wanting to write extra code. It's simpler, especially with microservices, to just build functions. And another question here is, how is Docker related to a microservice? Is each service run on Docker? Okay, let's tackle that one. So, how is Docker related to microservice? Related to microservice. The couple takeaways here are that, remember that Docker itself is two things. Docker is a runtime, and it's also a file format. Mostly those are the two things. Now, Docker has a hub, and you can keep pre-built images into a hub. So in getting into a microservice, one of the things that's good in terms of a microservice architecture that's modern is that it's small, and also that it would be better if you could package the runtime itself along with the actual source code. And so yes, in the case of a microservice, if you're able to literally package, the exact things that the microservice needs, like, maybe it needs some kind of C library, it needs a certain version of Linux, it needs some kind of GPU driver or something, all these really complex things, that by using a Docker file format, you can build out a Docker image and then shove that image into a hub. And it could be either Docker hub, or it could be a Clouds hub, like Amazon has something called ECR, or Elastic Container Registry. Google has a container registry. Azure has a container registry. So you could have a container registry, and then when you deploy the microservice, it just pulls the image down, and then you would run that microservice by executing that pre-built runtime. So yeah, it does actually highly relate to microservices, and I think most people building microservices are somehow using the Docker file format. Now, the microservice itself, the execution environment is slightly different, because it could be something like Kubernetes, and that's the thing that actually executes the microservice. But it also could be AWS Lambda, right? Which would be, in a sense, a competitor to Kubernetes. It could also be some other environment. It could be, a PaaS, right? A platform as a service. Underneath the hood, they're probably all using some kind of Docker format file with Docker images. But the microservice execution environment and then the network orchestration layer could be many different things. Okay, another question here is, how do I run Python when I can't install Python on a device? I'm using a storage device which doesn't come with Python installed. How to run Python code without installing Python? I don't know if I have a good answer for that. That's one of the things that you could do potentially for running Python would be, if it's able to run a container, you could actually execute a container that had Python installed. That might be one way to solve it. And another question is OO is best where you have an ORM mapping to a database, or another use case of OO over functional? Yes. So in that example of an ORM mapping to a database, keep in mind that the framework developer created the framework for you, and you as the user are not necessarily creating classes. You may be, but you could just be using the object that someone else gave you the ability to instantiate. And another question here is, any performance hits with using virtual environments in Docker container? No, I don't think there's any performance implications. Now, you don't necessarily need to source a virtual environment in a Docker container, but you may want to create a virtual environment to build the Docker container, if that makes sense. But in a Docker container, I don't necessarily think it buys you necessarily. It may or may not buy you something to use a virtual environment. I would probably, use it just because that's what my build process would be. I'd probably default to it, but yeah, there shouldn't be a performance hit. Okay, good questions here. Let's see, in the final section, I was going to go more into the details here on continuous integration and continuous delivery, and I was able to set up some of that already in terms of creating a Python virtual environment, and then also getting linting and testing and building all that stuff up. So, and we also were able to talk about continuous delivery. So we're a little bit ahead of schedule on that. So what I'm going to do then is I'm going to talk about microservices a little bit, and I'll get into using microservices on the AWS cloud environment, which is a great way to build a microservice. So first up, let me just show you an easy way to build a Lambda function in Python. So this is something I think that's a great skill to have. In order to build a Lambda function on Python, what we can do is, and this would be a microservice, is I can just say create function right from here. And I have a few options. I can author from scratch. I can use a blueprint, which is pretty interesting because I can look at how other people have done things, or I can even look at full applications. Like, they have like fairly sophisticated serverless applications that I could mimic. From here, I'm going to just build from scratch though, and I can choose the runtime. Now, in this one, we can see the latest supported are Python 3.8, or Python 3.6, Python 3.7. Because I know that the environment that I'm in has Python 3.7 in AWS Cloud 9, I'm going to pick Python 3.7, and then I'll just call this one Marco Polo 10.8. And I'm going to build a really simple function that demonstrates what you can do with Lambda. When you're first creating a Lambda as well, if you need to call out to, let's say, a service like DynamoDB or S3, you would need to set up permissions here. In this case, though, I'm just going to create a function, because I don't need to call out to anything. And really, to write a Lambda function, it's similar to just writing a Python function in Colab Notebook or Jupyter Notebook. I would scroll down to their code editor and just start writing some code here. So only thing you really need is just this one line of code, just like that. That's the only thing that is necessary in a Lambda. So I'm going to get rid of everything and just keep that one line of code there. and I'm going to just tweak this. So I'm going to build a handler here that will look at the events that get passed in. So I'll say, first I'll just print out what the event is. So I'll say, this is the raw event. And notice how I use an F string, and I'll say event like that, and then I'll close out the bracket. And now what I'm going to do is I'm going to say if the event itself, the name of the event, matches the word Marco, return back Polo. Otherwise, what we can do is we can return back no, right? So it's a very simple function that accepts an event, looks for a name in the event, and then returns back the word Polo if it matches Marco. Otherwise, it returns back no. So I can go to, I can basically test this thing out now. And the way I can test this out is I can actually go and build up a test function. So I'm going to go here and I'm going to say configure test event, and I'll say Marco as the name. And what this does is it creates a JSON data structure that will be the event that gets passed in. And from here we can say name and then Marco like that. And if I say create and then I click on this test button up here, this will go through and run this. And I can look at the results. There we go. We can say hello from, I didn't save this, so let me save it first. Huh, that's weird. I don't see save here. they must be, that's so strange. What? For some reason, they've changed this console where they changed the UI completely. Strange. Okay, well, I saved it manually, but they used to have a save button here. They must have just changed this. But if I go test here, let's double check here. What the hell did they do? This is totally different. You used to, because look, it's running the old version. Okay, let's see, publish new version. Let's just do that. I don't know why they changed the console, the Lambda interface here, but let's see if hopefully that works. Huh. Yeah, I don't know what they just did. Test. Actions. Well, now I don't even know how Lambda works. Well, I'm going to do it from a different interface. They literally just changed the interface for this like a day ago, and now it won't run my Lambda function. But the concept is, I'm sure that's a bug or something like that. Let me show you how you can do the same thing inside of Cloud9. I'm going to go to Cloud9 here. I'm going to click on this, and I'm going to go to local functions, and I'm going to click this icon. And this is actually kind of easier anyway, and just say Marco Polo. We'll say Marco Polo like local or something. And then I'll do the same thing. I'll say runtime. I guess in this one it says Python 3.6. Sure, we'll use Python 3.6. And then for trigger, I don't need to trigger anything. And I can just say finish. And it'll create this structure for me. Oh, you know what? The problem is, I believe, is that this doesn't have Python 3.6 installed on my machine, which is kind of funky because I'm using Amazon Linux 2, which doesn't have it. So that's one of the downsides of this tool, the Cloud9 environment, is that it's very old and that it will use an older version. So, but we can fix this. So what I'll do is I'll just close this out, and I'll go to Cloud9 again, and I'll open up a new instance, and I'll use an older version of it. So go through here. In fact, I can just grab a project like, here we go. Here's Here's a one I already have running, and I'll just open this one up. So this should take just a second here. Okay, so in this case, I can just close some of this other stuff I had running here. Now, AWS, if I go back and now in this environment, I can double check that I have Python 3.6 on here. Okay, good. I have Python 3.6 that, again, Cloud 9 is a little behind in that it wants you to run Python 3.6 runtime for Lambda functions. So what I will do is I'll make a new Lambda function here locally, and we'll call this Marco Polo local, and just do the same thing I did before. So runtimes, empty, no triggers. In a way, it's actually good to have errors because it is a great way of ensuring that you really understand what's working. If you don't have errors, then it's easy to kind of fool yourself into thinking that you know exactly how it would work. In this case, though, we should see this created here. And Marco Polo local, there we go. So it created this environment here. So I can just go to this environment, Marco Polo local, and inside of here, it should build out a structure. And what's weird about this is they must be changing all kinds of stuff with Lambda. I must be like getting some kind of change that they're making, but basically there typically is a structure here that doesn't. Oh, here we go. It took a while. It took a while. I was like, uh-oh, now this is weird. But basically it gives you this scaffolding. And so it looks identical to what we saw earlier. So what I'm going to do is I'm going to go to I'm going to do the same code that I had before. I'll say print, and I'll do fstring and say this is my raw event. And then I will go through here and put that print statement. And now I can just do the same logic. And I think I even have this. Do I have this? Yeah, I do. So I'm just going to paste this in. I already wrote the code. So basically it says this is the raw event. Look for the name. So how do I test this locally? What I can do is I can right click this and then say run local. And from here, we can just test it out. I can just say name is equal to Marco and then run it. And this should print out a result locally here. We can just move this down. Might take a second to wake up. Not sure why this thing is taking a second. I'm going to refresh it. It's just it's a not a super powerful machine, so it might be kind of slow. There we go. Let's run this again. This thing is not, for some reason, it's not happy today. There we go. Hopefully this works. Yeah, so it looks like it should be able to get this working. Give it a second here. don't know why it's hanging, but let's pretend that this works. I don't know why that's hanging, but I'm gonna go back here and go to this function, and we can deploy it into the cloud, which is pretty cool. So if I click on this deploy, it should deploy pretty quickly. And then assuming that worked properly, I would test it, and then I would just right click and it would do a deploy. And it uses the I think the SAML tool, which is a serverless automation tool. And you could also put that into a build process using, let's say, AWS code build. So this looks like it's deployed here. So what I'm going to do next is I'm going to go back to Lambda and take a look at that Lambda function. And we'll go here. And here we go, Marco Polo. That's 11 minutes ago. I don't think I want that one, though. I want... this latest one. So it would be last modified. So it must be still pushing this change. I don't know why this virtual machine seems to be struggling for some reason. It's not happy. Oh, there we go. So it looks like it changed. And if I refresh, there we go. 21 seconds ago that made the change. So if I click on this, we should be able to now test this out locally. So now I can do the test event, and we can say Marco. So it was a little bit of a journey to get it over here, but we can say name and then Marco, and this should test this out. Format the JSON. Notice how it can kind of clean it up for you, create it. Now if I test this, this should give us back what I was expecting earlier. There we go, Polo. So to test out this part, what I would do is I would say configure test event, and then I would make a new one, and I could use this as a template. And from here I could say Bob, and here we go. We'll say Bob, and we'll go ahead and create this. And if I test Bob, look how it says no, because it went through this line of code. So this is really a pretty simple example, but it shows how you could build a microservice using Cloud9 and then deploy it directly into this environment. Now, one of the things that typically people would do in a more sophisticated Lambda environment would be to add a trigger. And that's what this whole testing thing does here, this test interface, is if I go to configure test events, notice if I say create new event, I can look through the event template. And the event template has a ton of stuff like Amazon Lex templates. So this would be for chatbots, for example. So if I wanted to grab some chatbot messages and process them automatically, I could just use this as a template. And these are all fields that I could access. So that's the advantage of using this deep integration. Also, if I wanted to go to a mobile backend, right, I could look at a mobile backend. I could go to Alexa, write again, something that can respond to Alexa events. SageMaker. We could also go to AWS, tons of different things inside of here, like API gateways, Dynamo updates to the database, S3. This is another one. Let's say I wanted to automatically find the labels to an image that I put inside of S3, or resize an image or something like that. There's, this would be the way I would do that. So that's really the power of a microservice using Lambda, is the deep integration with the triggers. It also has really good instrumentation. As I mentioned earlier, that this is critical with cloud computing, to have deep integration with the log files. And so you would not only want to look at the invocations, the duration, the error counts, visually look at this, but also you'd want to click on view logs in CloudWatch and specifically line by line, check out this source code to make sure that you can dig into it and see what's happening. So here we go. Here's that the example where this is the raw event, and then I can say this is the raw event, and I can see exactly what's happening in my source code. So this is really critical. If you don't have these print statements or log statements in the Lambdas, it's almost impossible to know what's happening. You're just guessing, and so you don't want to do that. You want to have inside of here instrumentation. So you can use print, or probably a better idea would be to use log, the Python logging library, and you could log even context as well. So you could log, things about the application, or some specific event, like I'm processing a specific SQSQ or whatever I wanted to do. So in a nutshell, the AWS Lambda is actually a great way to build microservices and even web services in a high level way. So for example, if I wanted to turn this into a web service, how would I do this? I could just say add trigger and go to API gateway, and then decide to create a new API, and then I could say what's my endpoint. I could say open, and then add this up, and then now I would basically have a web service that I could call, and I could actually just test this out locally by calling this web service and then executing it. So pretty easy to build a web service automatically by using a Cloud9 plus AWS Lambda integration. Now, one thing that I have time to show as well with serverless is that there's other clouds that have serverless as well, and in particular, GCP has a pretty good serverless option here. And let me just show you how you could do similar things with GCP. So if I go to console and I log in here, one of the things that you can do with the GCP option is that if you go to functions, they have the same things. They have cloud functions, and it's the same concept. And in particular, I have some cloud functions already built here that I can show you. So here's one that I built that's I think pretty neat. And this is a function that, if I look at the source code, it will take a translation payload. So basically I can give it some text and it'll translate it to any language I want using their API. And then I also wrote a handler that can go through here and basically accept a payload and then send it into their API. And so I use the Wikipedia library to grab a web page. I then use Google natural language processing to translate it, and then I return back a translated version of Wikipedia. And so how do I do that? Is I accept a JSON payload that has entity, language, and sentences. Those are the three payloads. So again, this is a pretty good example of quite small microservice. It also uses functions, right? And it's 40 lines of code, but does a lot of stuff. Notice that it has a main file here and requirements, so it understands requirements. And look, these are the dependencies. So how do I test this? So I could do it from the console. It just needs to have entity, languages, and sentences. So I'm going to go ahead and test this. I'm going to say, entity, and then we would say, let's do Google, and then we can say languages, and we can say, how about Spanish, and then sentences. So how many sentences from the Wikipedia website do I want? Let's do, 5 sentences. And let's go ahead and test this function out. And if I've got the payload correct, it will go to Wikipedia, grab the web page, translate it, and then return back the result. So in theory, it should have done that. Details language. Languages. I think language. That's where I must have messed it up. So let's try that. So we can see it's running. Details, Google does not match any pages. Okay. That's weird. Let's see here. What I can do is I can actually, I think I have this in my history. Let me see because I also can call this function from a command line tool as well. And so if I go to history here, we can find, and I can grep for function or something like that. So yeah, here we go. I need to say entity Google sentences. Yeah, so this should be a good payload, entity Google sentences. So let's try this from the command line first. Let's just go ahead and try that. This probably looks good here. For some reason, I'm in the wrong. I would have to change the accounts, but basically I can just effectively run it from command line. I can also run it from here. I don't know why this is giving me. Maybe was it entities? Is that what I'd have to look at the source code real quick. Let's just look at the source code real quick here one more time and see if we can get this working. Not a big deal either way, but it accepts, entity language sentences. Okay, let's see, entity, try one more time, entity and we'll say, we'll do a different company, I don't know, how about Facebook? And then we'll say language, and we'll do Spanish, and then sentences, we'll do 5. I don't know if it takes an integer or a string, but let's see if hopefully this works. There we go. So it worked. Maybe I was passing in a string instead of an integer. But basically, that's kind of the point, is that I can build these small functions that do work, and maybe that's some part of a pipeline. And then to create a new one, pretty easy to build new functions. You can decide what the trigger is, right? HTTP. There's all kinds of new functions available as well, like analytics or storage. But this is definitely the new way that people are building things in a cloud platform. When you think of the word DevOps, I think a good way to consider what is a DevOps lifecycle is this concept of a feedback loop. And this feedback loop is something that is seen in other industries. So a really good example is in post-World War II, there was the automobile industry in Japan, we'll just say Japan here, was a great example of how you could apply statistical techniques to quality control. And if we look at a bell-shaped distribution or normal distribution, you know that the median right here, this is the center of the distribution. So let's say these are cars being produced and without defects, right? And if you see that if we did one standard deviation away on either side, or we had 2 standard deviations away on either side, and then you get to 3 standard deviations away on either side, essentially all of we'll say 99% or so of every event occurs within 3 standard deviations away. And that's really the concept of when someone says Six Sigma, what does it actually mean? Well, it means that most events occur within 3 standard deviations to the left or the right. Like, is this wheel, a certain amount of centimeters big, 100 centimeters, it'll be within 3 standard deviations left or right. And that concept really came about in terms of wanting to build better cars. And so there's a word, Kaizen, that is part of this Six Sigma culture. And what it means is continuous improvement, literally in Japanese. And this is really the concept that DevOps has stolen. And it's something I've definitely seen in my career, is that really your goal in doing DevOps is on a daily basis is you want to improve, right? And that's really at the core of DevOps is are you making things better on a daily basis? And this is in some ways counterintuitive to, let's say, a startup culture. I think it's starting to change a little bit, but a lot of times at a startup, they want you to build features, right? So let's say you're working at a startup, and maybe there's a reward for the number of features that are developed in a mobile app. Well, in this case, in the startup world, that may have some kind of a conflict with the improvement, right? Because it's possible to increase the features, but then also decrease the quality of the code. And so there's a conflict. And really, that's one of the things that DevOps helps to solve, is that instead of just focusing on, am I producing features, a different approach is, am I constantly improving, like on a daily basis? Is my code base getting better, or is it getting worse? And again, going back to this Japanese automobile industry where they come up with this word Kaizen, of continuous improvement, it's the same thing. If you're automating something, you need to automate the high quality version of it. And if you don't automate the high quality, you're going to automate the low quality version, and you'll make it worse. So that's really what DevOps is it's a process of making things better over and over again. And related to this, I'll make another screen here, is this 5 whys method. And this is something you may have come across in your travels. And so 5 whys is a technique that allows you to get to the root cause. And this is really related to Kaizen as well. So let's say that you're working at a company, and I'll tell you a real story that I had. I was working at a company, and there's a cluster of machines that were, it was a software as a service company, and we analyzed log data. And all of a sudden, every once in a while, a machine would die. And we had no idea. And it was really irritating, because the machine would take, let's say, 4 hours to rebuild. I mean, we had backups, but it would essentially reduce our capacity for 4 hours. Our system would be a little bit busier. And then sometimes if 2 went out, it would actually, make our system run a little bit slower than usual, because we're at reduced capacity and we had to restore all this data. And it was really not a good situation to be in. And so this was a perfect example of, a 5 whys. So let's go through the 5 whys here. Is, why did the machine crash, right? That's question 1. So why is there a crash? And then say, well, the machine has no swap. And then we say, well, why was there no swap? Well, someone told us that it's better for a machine to crash. So we said, someone configured it that way. And then the next question is, well, why can't we configure it in a way where it doesn't crash, so we can investigate what's going on, so don't crash. And then someone would say, yeah, you're right, we should try that. And then say, well, once we've tried that, why don't we figure out why it's actually crashing to begin with, right? And so this is a an intentionally kind of a simple example, but this was a real example that we had where we just didn't go through the 5 whys to figure out why a machine was crashing. And then eventually, once we dug into it, we realized that it was actually a very complex, subtle problem that we never would have seen if we wouldn't have let the machine stay around for a bit so we can investigate what the issue was. What was actually happening was, it's actually similar to the outage, I guess, that Amazon had, in that we had a Java machine. So we had a Java machine that was running Elasticsearch, and this Java machine, the memory was configured to, let's say, 2 gigabytes, but the machine had, let's say, 1.5 gigabytes total. So it normally wasn't a problem, except for when it started to get busy. And then once it starts to get busy, what would happen is the Linux kernel it has something called OOM, which stands for out of memory error. And the OOM would then go through and it would kill the main Java process. So to restart it so that it would use less memory. The problem was we had something called a supervisor, and the supervisor would actually wake up a process if it accidentally died. So there was actually a race condition where the machine would keep fighting itself when it got busy, and this didn't happen that often, which made it worse. And then it would slowly kind of kill itself. And then when it got into this death spiral, so we'll just say like a death spiral here. When it got to the death spiral, the other problem was that there was no swap, so we couldn't figure out what happened. So it was a very subtle, weird problem where the only way you can solve a problem like that is you have to use something like 5 whys to start breaking through and getting into, you know, the root cause of it. So let's talk a little bit more about what are some things that could have fixed that particular problem. So in particular, this is where DevOps comes in and really saves the day, is that in particular, and we'll get into this later, this concept of continuous delivery really can be one of the solutions for it, or at least part of the solution, where if you look at source control here, and you have, let's say, GitHub, and the people in your company are building software and they're checking things in, typically you could have in number of branches. So you would have a master branch here, and then you would have a staging branch, and then let's say you would have a production branch. And some of the innovations that have occurred in the last, let's say, decade or so have been that in this step right here, if you use infrastructure as code, what can happen is you can dynamically create these environments. So you can have a development environment that is, you know, dynamically created. You can have a staging environment that's dynamically created, and also as production. So you know that not only are you testing the code itself, but you also test the infrastructure. And this allows you to do a lot of really advanced forms of testing. And in particular, back to the failure of the machine, what we could have done is in the staging environment, you know, let's say we have a workflow where we check the code into master, then we check it into staging, and then we check it into production. What we could have done was have a load test that always runs our search engine and ensures that we know what happens when it reaches a failure state, right? So we could have easily caught that bug by doing a load test that brought the system to 100% capacity and see what happens when it fails, and also tested the elasticity as well. So we could ensure that our DevOps, you know, workflow would work, where once the machine, let's say there was a load balancer here and there's 3 nodes, we could ensure that in fact there was a 4th node would spin up, and we could also ensure that there wasn't weird, you know, random failures, because what we could do is we could look at, let's say, a monitoring dashboard that would show us what's going on. So that's really one of the big takeaways here with DevOps is because you're automating not just the testing of the code, the testing of the infrastructure, and also the creation of the infrastructure, you can build in automated additional checks that do much more complex testing, like load testing. So if you are running a software as a service company, really, I think it's almost negligent to not do some form of automated load testing, because you need to know what happens when your system has high capacity. And this is, I guess it's related in a way to, people talk about chaos engineering, and it's similar concept, is that you want to see what happens when things are not necessarily going the way you would expect them to go. And that's really what a load test or some kind of chaos testing really does, is it benchmarks what happens, when what you expect happens doesn't happen. To get started with serverless, which is a best practice, let's go through and document a little bit about serverless and microservices, and what's the point, and why is this even anything to do with DevOps. Well, to start with, a serverless and microservices are DevOps best practices. So DevOps and microservice are closely related together. And part of the reason behind this is that in the old days, let's say from 1970 to even, I would say potentially 2005, something like this. This is, we'll call this pre-cloud era, right? And in this era, people are still hyping these technologies. They're hyping these kind of like monolithic frameworks. And so this is where you hear about web frameworks in particular. And this is I would call this like legacy thinking, right? This is thinking that everything should be this giant monolithic. You'll see that everything has to be a relational database, RDB, plus almost as well a CGI web request model, also templating, and people are using like templates for the server itself is essentially translating JSON data back and forth. So this is all like a legacy way of thinking, and it's really expensive computationally. So we know that it's low efficiency as well, and it also is difficult to debug. Debugging is difficult, and also has lots of security holes, right? So this is really, I think, the old way. The new way, so we'll just say, the modern era, and I would say probably 2010 plus, and maybe even we say 2010 to potentially even, let's just only cover the next 10 years. So we'll say 2030 is this DevOps world. And the DevOps world says, look, all that stuff, hey, it got us to where we're at now, but really there's some big problems. And one of them is that a microservice is a lot easier to maintain in that it does a specialized task. And that's really one of the reasons for a microservice. Also, the complexity is low. So this is really a key component of this. Also, the other thing that's about a lot of these frameworks is that it's almost like a cult, where you're caught into this world where everyone has to talk the same language. But a microservice like Flask, for example, really lets you get out of that cult and think for yourself, where you can use this microservice in any environment you want. So Flask, for example, fits really well with potentially any cloud. You could have the same Flask app, and it can be applied, in a container, or it can be applied as maybe a microservice or whatever it is you're building. So I think this is also a big takeaway here, is that less is more in the DevOps world, and also that the runtime should be encapsulated with the microservice. And then further, even Flask in a way is a little bit legacy, although it's a microservice, in that it's really not event driven. And so that's something we'll talk about as well, is that a lot of the Lambda services allow you to, or Google Cloud allow you to respond to an event, which this world is only basically pull based, right? Where you're in a loop and you're just constantly just burning down trees in the forest somewhere to get your server to run, where this can just be waiting for you patiently and not doing things. So this is another, I think, often not talked about problem with this legacy world of web frameworks that everybody's pushing still, surprisingly, is that this is bad for the environment, right? So if we look at the word green, this is horrible, right? We have really inefficient servers we know that the science says that climate change is real, it's not fake. And we have these really expensive servers that are just running for no reason, where if we built an event-based architecture, the events are a much more specialized way to run. So that's just another thing that's kind of not necessarily talked about enough. And even if you don't believe in climate change, still, why would you want to pay extra money when you could do an event-based architecture? So I think that's a key takeaway here. So now that we know the architecture of microservices and DevOps and why the legacy world needs to be abandoned, let's dive into a repo here in this serverless cookbook. And in particular, this cookbook has a few different things that we can run. The first one would just be this Marco Polo AWS Lambda function. And what I'm going to do here is also do a quick sketch of what the point is with these serverless functions. So I talked about polling, right? And I think the best analogy that I will use, that I typically talk about for what are we building, is events. And again, this is directly in opposition from 1970 to 2005, where the legacy world of web frameworks, the new world is events. And the way events work is that it's much like what would happen in your house in terms of your garage. So we have a house here that's got some windows, and we have a door here, and then inside of this we have a garage. And inside the garage, there's, let's say, a light bulb like this. Now, think about all the different ways that a light bulb in your garage could be triggered. Well, let's look at one. So one is the door opens, right? So this open event we could subscribe essentially this light bulb to the open event, and then all of a sudden the light bulb turns on, right? So that's one way we could handle this. And just like the example of the really poor performing legacy architectures of web frameworks, you don't want to just leave your light on in your garage 24/7 just to burn, electricity. Why would you do that? You're going to have a high electricity bill. Instead, why don't you respond to an event, which is the door opens and then the light bulb triggers, and then the light bulb maybe stays on for like 2 minutes, right? That's a pretty elegant architecture. But that's only one of the events that you can do. The other thing you can do is you can say that you can manually turn it on. Like, why not? Why not also, whenever you want to, you just click the light on, you have to do something in your garage, and then you click it off, right? So that's a second kind of event. And there's even a third kind of an event that you could do, which is a timer, right? Where, and again, this really is something that's very common in the cloud, is you could say, listen, from midnight, to 1 a.m, I want you to turn on just so that it's like a deterrent for burglars. And I want this timer to turn on, and then it'll turn off at 1 a.m. So this is such a more powerful and more efficient approach. So serverless is basically, let's look at all these benefits. It's more powerful. So it's got more power. So we'll say power is greater. We also it's more efficient as well, because you're only being charged for when you run it. And also it has the ability to be solve more problems, right? And so it's part of a more complex potential solution that you could build. So there's many benefits to using serverless. So let's now dive with that kind of background behind us. Let's dive into building a function in Lambda. So first I'm going to log into my account here and do my auth really quick. And here we go. Let's go ahead and log in real quick. All right, so in AWS, if you want to run a Lambda function, what you can do is just go to Lambda. And in fact, now Lambda support containers, which is pretty awesome. So look, you can say, look, container image, right? Which is totally awesome. We're going to do one from scratch here, and I'm going to call this Marco 2030 to represent the future of how we should be building services. I'm going to select Python 3.8, and then if I create a function here, the way it works is that it'll give me a IDE that allows me to play around with this particular service. So let's go ahead and create this function, and it creates this version here. I'm going to click on it, and then I can go to the code section here and actually start writing out my function. So it's kind of similar to like a Visual Studio Code development environment. The key takeaway here, though, is this event again. This is where everything happens magically, and if I test it, it's just going to send a JSON payload into this event. But if I want to do a trigger, which if I go to configuration and I go to triggers, this is where you would set up, again, back to the light bulb analogy, right? If I want to set in any of these three kinds of triggers, I would set in the trigger there. So let's see how you would do this. You would go here and you could say, I want to create a web service trigger, or I want to have an IoT device trigger, or I want to do voice recognition trigger, or I want to do, event bridge, right? Which is basically events. I could do a trigger on that. That would be a timer. There's tons of different ways I could trigger this. S3 is another one where you could have a bucket. You put an image into the bucket. It triggers the some kind of event, and then let's say you have Amazon recognition, label the image or something like that. There's lots of ways to trigger. Or SQS is another one where if you wanted to build a high performance processing engine, you could use SQS, and you could just process millions of requests if you needed to. It essentially, SQS handles unlimited amount of traffic. So now that we know that, what I'm going to do is go back to my serverless cookbook here, and I'm going to go to this Marco Polo Lambda and just kind of copy this out. So let's go ahead and put this first part in and put it into the code. And notice what I'm going to do here is I say, if the event has the word, if it has a name in it and it has Marco in it, return back Polo. Otherwise, return back no. And so I'm going to go ahead and deploy this, and then I'm going to click on test. And all you do to create a test is put in a JSON payload here to test it out. So let's go ahead and do this. And we'll say name is Marco. There we go. And we'll invoke it. And when we invoke this thing, you should see that the Polo word appears back, right? So pretty easy to test. And now let's do a bad request. So let's have one called Bob. And then here, if we put Bob in, Bob should get a no. This thing says no. There we go, right? So pretty easy to test a Marco Polo function. And so I like to do the Marco Polo because it's just intuitive, right? Is I have an event, it has to match. If the event matches, I do one thing. If I don't, I do another thing. So what's neat about this Lambda service is that we can expand it and make it do even a little more magic by a couple different things. One, we can invoke it via the command line. And so I'm going to create a second environment here using Cloud9, which is similar to GitHub Codespaces. I have one, I could either set up a new one or have one already existing. I'm going to create a new one real quick to show how to do it. And we'll just say Lambda Central or something, right? Where I want to play around with my Lambda functions. And by default, I believe we can just say everything here, Amazon Linux 2. We'll use Amazon Linux 2. And then we'll say next. There we go. What's nice about these cloud environments and why I mostly do my code for a particular cloud environment in their cloud shell is that they already have the tools pre-installed. Like, I'm lazy. I don't want to do a bunch of work, again, like install the SDK and all the stuff. Like it's all ready for me, and it has the right role-based privileges to do these invocations. And so in here, we'll just take a few seconds here, and let's let this scroll. What this will allow us to do is, if I go, while this is spinning up, I'm going to go back to this command, which is this lambda invoke, and I'll show you how cool this is. So here we go. This thing should be ready in a second. Okay, so this thing's woken up now. So why it's awesome, there's a lot of reasons why it's awesome, but one of them is that you have this shell that's got AWS already installed, right? So if I wanted to list my buckets in S3, there you go. I can list my buckets. In this case, though, I want to run this command, which is this. I want to invoke this Lambda. Now, I actually want to invoke this one, which is called 2030. So let's go ahead and do this one. We'll just say 2030. And in particular, here, let's look at the different things that I'm going to do. So I'm going to say payload. So I'm going to basically make a payload, and I'm going to put in the word name Marco, and then I'm going to tell this command to capture the output of what happens here, and then just basically print it out. Now I could just take this part out to be lazy initially. Payload lambda invoke Marco Polo function not found Marco Polo. That's weird. I'm not sure why it's not finding this function. I certainly seem to have. Maybe I'm misspelling it. Let's try again. And let's see. Did I spell it differently? Maybe I have different caps or something. Oh, Marco. That's why. Okay, so let's go ahead and run this. There we go. So it ran it, and look, it creates this output. And notice that there we go, Polo. And if I want to say, bad out, we can put in the word Bob, and we can actually also test this out. There we go, bad out, and then it has, there we go, no, right? So in my opinion, these lambdas are one of the coolest things you can possibly play around with because of how much awesome things you can do. And this is, again, just an intentionally simple script, but imagine you have at your fingertips basically infinite concurrency, because these lambda functions can run, basically true parallelization, where Python itself, the language, has some real big critical flaws, like you can't do true concurrency with threads. But if you use the cloud itself can do the true concurrency. So you can invoke concurrency from a command line tool, for example. So this particular function here, one of the other things we can take a look at as well is if we go to monitor, now I can actually go to the logs, and I can look at these logs actually right here, which is pretty awesome. And I can see everything that's happening. And if I go to the log stream, it'll show me all the invocations, and I can track down exactly everything that's happening. So here we go. We've got the different statements. I believe that this is the one that I care about here. Now notice that there's no log messages inside of here. It just shows me the invocation. So how would I change that a little bit? In Lambda, the way you would write logs is you just do a print statement. And so what I can do here, this Marco 2030, let's actually tweak it and make it a little smarter. And so I'll go here and I'll just put a print and say, print, this was the raw event, like that. And then I can put in the name of the event. So this is why F strings that we talked about are so powerful, is that they allow you to quickly build like a log statement. And then I could even put line by line some debugging, and I could say prints here, and I could say this event was Marco. We'll just do like that. And then I could do another one below here that said prints, this event was not Marco, like that. So basically it just shows me the execution path of what everything is doing. So we'll deploy this. And if I go back to my environment here, I can execute it, and instead of saying Bob, let's put in Sally, and there we go. It'll overwrite this, and we can look at this. We can see no. And then if I go back to my CloudWatch logs here, and we refresh, we should see additional messages here. It'll take a second for them to populate, but we should see basically new messages that have more output inside of them. So this one, here we go. There we go. The event was raw event. This was Sally. This event was not Marco. And we could go iterate from there and there and there. So that's really it in a nutshell why it's so powerful. Now, what else can we do that's cool? Another thing we can do if we go back to our serverless repo is that there is another thing that's pretty awesome. I guess maybe let's do this before I go away. Is let me grab this and I'll just put this as a file in there as a template, and I'll just say this is a logging version. So we'll just say create new file, AWS Lambda Marco logs. There we go. Just so there's another version of this. All right, let's go to this one though, the step function. So what a step function does is it allows you to chain multiple lambdas together and capture the input of one and put the output into another. And so how do you do this? Well, the way you do this is you, and I guess this link here is not working, but basically it's this is the way the code works, is that step by step here, I can just say, here we go, here's the first function, here's the second step function, and I just put these in together. So I'm actually going to build this from scratch. So I'm going to go and grab these together. I'm going to go to step functions here. And let's go to step functions. And I'm going to say create state machine. And I'm going to just do a regular step function here. And notice that what I can do is just paste it in like this. And notice that this word starts at Marco. This is Marco Polo. And I take one function here, and then after I take the output, I go to the Polo function. and then I do a finish operation, right? So I'm able to chain together something pretty complex. So let's go ahead to next here, and we'll just call this a Marco Polo, step function like this. And now for the role, because we're not calling any APIs, we don't need to do anything tricky. I'm just going to say create new role, and then I'm going to go ahead and create the state machine. Okay, perfect. Now that I've got this, how do I execute it? What I can do is say start execution. And similar in testing is I have to initialize this thing somewhere. And where I'll initialize it is by first, putting inside of here an initial payload. So I'll want to do name here at first, and we'll say name. And inside of this, we'll say, Bob again. Or in fact, actually, let's actually leave this by default. And I'm going to start this execution. And what's going to happen is that this will fail. It'll first, you can see that the input goes here, but it's going to fail because my function here isn't smart enough to handle that. Because if we go back to the lambda that it's calling, notice, let's look at the code for this lambda. It does nothing, right? This lambda code just accepts a payload like that, and if it doesn't match the word name, it just blows up. I don't handle that problem, and it returns back a dictionary, which is name polo. So in this case, it can't work. But what's cool about this is look how I can easily spot every single execution what the state is. So from a DevOps perspective, the fact that I can look at my pipeline step by step and see exactly what's happening really is powerful. And again, this is so different than, let's say, a legacy web framework that doesn't have these tooling. This is really the modern way to develop applications. So let's go ahead and fix this. So let's go ahead and create a new execution. And I'm going to put in the word name here. And then I'm going to put in Bob. So let's see what happens when we put Bob in. Let's go ahead and start this execution. And this should be a little bit different. So it got to Marco. We see what the input is. It says name. So it was at least able to accept it. And then, now it failed a little bit further. So why did it fail? Well, let's look. If we scroll down here, we see that this lambda was successful, but then it entered the Polo lambda. And what does the Polo lambda do? Well, it's expecting that this code will have the word Polo in it. If it doesn't, it then basically returns back a none value, which we don't know how to handle. So we have another problem that we need to fix, right? So it's stuck here. So how do I fix this? Well, let's go back to another execution and let's just fix this. Let's put in Marco, and what will happen is that it will be able to fully pass through all of these phases, because step one is we put in the word Marco, and what does it return back out? It returns back Polo. This one's expecting that you put in the word Polo, and if you put in the word Polo, it will then return back Marco, right? So it just transposes what goes in one function goes out the other, and then it runs a finished operation. And we can see the finished, if we go back here, is if we edit our step function here, that's just that final step, right? Which is it returns back finished. You could put in anything you wanted to do at the end. But this shows how you could build some really cool tools with incredible debugging and logging by using AWS Lambda and or AWS step function. And as I mentioned earlier, maybe as a wrap up here, that what's awesome about the new Lambdas is that you can build them now with Docker containers. So if we go to container image, for example, and I just type in Python container, and I could say enter a image URL. What we could do is just browse a container, and we can see, here we go, it's a Flask demo, or whatever, anything from my Amazon image repository, or I also could check in my own container and overwrite it and build things in here. So there's a lot of new things that are developing with the Lambda functions as well. The last thing I'll show you with this is that if you go to this tab here, AWS Resources, one thing that you can do is you can actually import a function remotely. So if I go to AWS Resources here, click on this, and I go to Marco 230, which is, well, let's just grab one. Let's just grab this one. I can actually say, double click on it. And what's nice about it is I can later, if I want to, tweak this code and actually add more information to it, right? So that's the other thing that's great about this environment is I can go through here and say this is an event, put some other updates to it, prints, and we'll just say f-string, this is not a match, right? Something like that. And then what I can do here is I can actually I can save this and actually test it out local. So test out my, let's just refresh this here. Test this out local. So if I right click, I can say run local, and I can test this whole workflow out. So say, name, and we'll just say Marco, what happens here. We're able to run it. Sometimes you have to kind of wake it up. The debugging takes a second to kind of wake up, but there we go. Let's see. The first time I do it, I've noticed sometimes you have to just do it a couple times, and then it wakes up. Anyway, I'm not sure why this thing is not invoking. It could be because I used Python 3.8 maybe, but in general, most of the time this works. Oh, there we go. So I must have been waking up. So there we go. And then if I type in Bob here, run this, we can see that this is the other pathway, right? And then if I want to deploy this, I can go through here and right click and do a deploy. And what's awesome is that's pretty quick. And then I go back to my functions here, and here's Marco Polo 9000. Look, I just updated it 4 seconds ago. And then I can test it out, go to this, and test the same piece of code if I wanted to, or even look at the code, and you'll see the code's exact. I added that code there. So really powerful development environment. So that's probably good as a stopping point for this section. Let's move on to a next topic here, which is the GCP cloud. So I covered these two, and in particular, GCP has some pretty cool stuff that we can play around with. And so here's a function that I'll just talk us through real quick, where basically this is a change machine. So what it does is it is a function that will return back the correct amount of change. And so I'm going to invoke this. I mean, I could basically very similar do the same thing on the AWS cloud, but I'll do this one in particular for the GCP cloud. So what I'll do here is open up GCP, and let's go to their cloud functions. And I'm going to log into the console, go to the console. And to build out cloud functions, pretty straightforward actually. You just go to a search bar here and type in functions, and they should pop up in a second. once it fully refreshes here. There we go, Cloud Functions. And inside of Cloud Functions, in order to create one, create function. And what I can do, that's annoying, is I can say new function name, and we'll just call this DevOps change machine or something like that. And I would decide what region I want to do. And just like any other cloud function microservice, I could decide what the trigger would be. In this case, the trigger would be a HTTP web service. And I then have the choice as well whether to use authentication or unauthenticated invocations. I think for demos, unauthenticated is the way to go. And so I'll go ahead and say unauthenticated invocations. I'll go ahead and save that. Go to next. And notice that we have a choice here of Python 3.7, 3.8, Node, Java, Go, .NET, all kinds of stuff. So I'm going to select Python 3.8 here. And in particular, you can see this is like a hello world type, template that they give you. But in our situation, I already have some code that I'm gonna throw in there. So what I'm gonna do is I'm gonna go to this and I'm gonna put in this payload here, which is kind of a fun little project. Well, what this does is it allows us to pass in a JSON payload that has the word amount in it and some coin amount or some raw amount like $1.34. And then what happens is it gives us the correct change and it kind of prints it out here. So notice that the entry point has to match. So in this case, this is hello world. And also, I think this is an advantage that this interface has a little bit over the Lambda is you can put the installs right here, which is pretty nice. So I'm going to go ahead and say deploy. And what this will do is put this thing into production. And that is really annoying feature of that window popping up a bunch. So basically, once this thing is been deployed, then I can actually start prototyping out this code here. And the things to look at are testing. And so under the testing window, it really wants that function thing to appear. So under the testing window here, what I would do is put in my payload. And so the payload would look something like this. It would be amount. I'll make this a little bit bigger. This is like conspiring to reset. I don't know, stop popping up. And we go here, we say amounts, and we say $1.34. And in theory, there we go. It gives me a 134. It looks like it's valid JSON. And if I say test, we can scroll down here, and there we go. You can see that it actually returns back the correct amount of change. And if I want to change it to other things, I can go through here and give it, I don't know, $10 and 44 cents, and then test that out and see there's a bunch more quarters, right? So we have a neat little service here to test out, but we can do a lot more as well. And this really shows the power of these cloud-based development environments. If I click on this icon, Activate Cloud Shell, what I can do here is get into testing this function out via a command line tool. And so let's go ahead and take a look at this real quick. And what I can do is look at this command, and this command in particular allows me to invoke it via the Cloud Shell, which is pretty awesome, right? So let's say that I built some kind of a computer vision pipeline and I have it triggered inside of here, or I have some kind of proprietary thing. I can again just treat it like it's a piece of logic that's deployed. It's just waiting for me to run it whenever I want to run it, and I can invoke it via command line tool. To me, this is actually pretty awesome. So I'm going to change this up here, and I'm going to type in DevOps change machine like this. And what we can do is actually invoke this like this. And it will take a second, and it's going to ask me to authenticate, which is fine. So we'll go through here and authenticate. Great. It's going to ask me to do this. I'll go ahead and authenticate. That's fine. Allow this, copy. And now if I go back here, I can enter this auth code. And what we'll do is I can now go through and execute that cloud function. It takes just a second to wake up. There we go. So now I can just, basically go through here and just start tweaking things around, and I can just run it as many times as I want. So I think this is an awesome workflow. That this is an intentionally simple application, but it shows how you could integrate this into a lot of different applications. Now, the other thing that we can do here is we can do more than just invoke it, via passing a payload in. We can also invoke it as a web service because it's got that trigger built in. And so if you look at this here, notice how this trigger right there is the URL. So if I basically just copy this trigger here, and I say, basically export URL equals this, like that. I could say echo $URL. There we go. So we got this URL stepped in here. And then if I go to a curl command, I can basically curl this and do some more tricky stuff to it. So if I go back to my Cloud Shell, I can tee up this command. Let's see if we can get this working. So I'm going to curl, I'm going to put in the amount 134, and then in terms of the actual URL, I'll just do this. I'll just say trigger, I'll just put in the $URL, just like that, right? And in theory, this should work. There we go. So then I can actually put in, different things. I mean, I guess I could be fancy here and even like let multiple things swap, like create different variables. I mean, I guess I could try that real quick. So what I could do is I could say, open editor here, and I could first grab this command, and I could make a little edit command in here to build a invocation of this. So let's scroll this up a little bit here and make this come up here. And I could write a very simple shell command that allows me to, via terminal, new terminal, there we go. Okay, so I can just say touch invoke.sh, and then where's my invoke.sh command? Whoa, got lots of different projects open here. There we go, invoke.sh, and let's just put this inside of there and just tweak it a little bit. So basically I could do a $sign here as well, right? So I could say $sign change or something like that. There we go, change. And if I just grab this, I could say export. Actually, I think this should be in my environment already, right? Echo. Okay, so I have to go back to this terminal, which is kind of annoying, but I'll just say export $change equals 134, like this. Oh, I don't need a $sign right there. There we go, export. Set this variable up, echo it just to make sure it looks right. Change. Now I might have to do quotes in there, like this. That looks right. And then if I put in this command like this, does that work? Uh-oh, I screwed something up. I think it's because I need to do this. I need to swap those and say these are the inner quotes are this, I believe. Anyway, well, something similar. Like getting into the bash scripting is less of the whole point here is that you can easily build out these invocations via web service, or you can invoke it via command line, and it's a great way to interact with your cloud function. So if you want to take a look at that, there's a example here that allows you to invoke this cloud function. Now there is another one that I have as well that's inside of here that I can take a look at since I have some time, that allows me to do something a little more complex, and hopefully it works. I think I'd have to look at the last invocation here. So I think there's a translation API here that I believe it's this one. This is a pretty good one. And inside of this, if we look at the source code, what it will do is a little bit more magic here. So let me just close this. So this is a good example of a slightly more complex function that I install a library called Wikipedia, and I also install a library called Google Cloud Translate. And if you look at the code here, the source code here, you'll notice that inside of this, I can actually translate whatever's passed in, and then I have a request here that allows me to pass in entity and language. So basically, what website would I like to translate, or what web page in Wikipedia, and then also what language. So I believe I can actually double check this by going back to here and going to Cloud Shell and looking at an example here. So I can say gcloud, I can say history, grep gcloud, and we can see here that there's, I think this is the one I called earlier. Let's go ahead and try this. And this would be a slightly more complex cloud function. And so it's going to ask me to do this again. So we'll go ahead and authenticate this real quick. And auth it, sure. Allow, copy, paste it in. And if I run it again here, in theory, it should look something like this. So basically, you can go through and translate. I don't know if this yeah, there we go. So you can see that in this particular function, I can pass in, names into this function, and right? So I can say, look, go to Google, go to Wikipedia, grab the Google page, grab 20 sentences and translate it to Spanish, right? And so we go here. So now Google, maybe Google doesn't match something, so we'll have to do maybe another one like Amazon. Let's try Amazon. So maybe AWS or Oracle. That's a good one. We have to find a name of a. There we go. Let's try Oracle. Yeah, so it doesn't necessarily have a ton of error handling. Well, we know one of them works. we know this one works. So and then if I wanted to change to different languages, I could just look at the different versions of languages. So I think like maybe is it Italian? Is that IT maybe? Let's see if that works. Okay, there we go. There's Italian. We could also see CN. I think is probably Chinese. No. RU is maybe Russian. Just guessing. I don't know exactly the different languages. There we go. Yeah. So if you want to set up a continuous delivery, probably again one of the cleanest ones is most likely GitHub, Google App Engine. So let me just show you how CD works. CD plus Google App Engine, GAE. So how would we do this? So the way it would work is you would go through here and create a GitHub repo. And then inside that repo, you would have, I think we have time to do this from scratch. We would have a Flask app, like a Hello World Flask app. And then we also would hook this up to their cloud build environment, and it would auto deploy. And so that's what I'm going to set up is every time I make a change, it auto deploys this Google App Engine, and there'll be like a change app or something like that. So let's go ahead and build this real quick. Again, I think I can get this done within potentially 30 minutes or so. We could just crank this out real quick. So in order to do that, I'm going to create a new repo from scratch, and I'll go to GitHub again, and let's just make a new repo. We'll call this Google App Engine CD or continuous delivery. Continuous delivery. So automatically deploy code for Google App Engine. Okay, and let's go ahead and add all this stuff in here that's useful. Python. Let's do that. Okay, and I'm also going to select this here because this integration will let us do the continuous delivery. So here we go. Here's this thing, this repo, and I'm going to go down to this as well. And boom, there we go. Okay, so now that I got this thing hooked up, what I'm going to do is check this out in my Google Cloud environment. So it's already ready for me here. So I'm gonna deactivate this other virtual environment, and then I'm going to CD up a directory, git clone. Check this out, and then I'm going to do the same thing I did before. Right, it was virtual environment ~/dot. And I'm just going to add this into my home directory like that. And then I'll source it and do GAE, continuous delivery bin activate, just like that. All right, got this thing cooking. And then from here, I'm going to create this basic structure as well. So let's go to, let's see here. Let's go to this last command. So I'm going to GAE history. So this is the one I want to CD into. Okay. Oh, actually, I think I need to just CD into this. There we go. All right. So I got this thing. I got this thing cooking. So I'm going to do the same thing I did before, which is really quickly just create some stuff. I believe it's going to need a make file, and then I have some of this code from a different project. So I'm going to just copy some of this GCP Flask ML deploy. This probably is it. Let's see here. App.yaml. We're going to need that. Yeah, so I'm going to just copy these one by one. So I got app.yaml is one of the things. Yeah, and let's just double check that it's the same. Yeah, app.yaml, we need that. And we're going to need, in fact, since I'm here, I might as well just put it in there. So we're gonna need to put the runtime inside of what we want it to be. So it'll be Python 3.8. Great. There we go. Got that created. We're also, I'm actually going to make a new project as well inside of GitHub. And we'll call this GAE deploy, GAE CD, continuous delivery. Go ahead and create this. And I believe I'll need to change this environment. Hopefully it lets me create a new one. Sometimes I create so many projects that it gets upset and doesn't want me to create more of them. But okay, there we go. So, and I think I'm going to need to just close this shell and open it back up again so it'll correctly source that new project. Okay, that looks good. And then I'll CD again into, not this one, into the project that I was just setting up, which is here. Repositories. There we go. So this one, go here, clone it. Okay. So the reason I did that was so that I could get the project refreshed here. So I just need to, what was it? Yeah, this one, continuous delivery. So CD into GAE continuous delivery. Okay. And then I can source that same thing, then activate. So I guess if I would have created that alias, it would have helped me out to remember all the stuff. Got that working. And what else do I need to set up in here? I need to set up the Flask file itself, which is this one, which is just a super simple Flask app. Let's go ahead and just copy that, paste that in. So, and it has to be called main.py if you're doing this. And so if we go main here, notice that I just pasted in a kind of really simple Flask app. In fact, I think I'm just missing a line of code, which is from Flask, import Flask. It's just an echo command line or Flask app. Okay, that looks good. What else do I need to create in this repo? I need to create a requirements file, and just Flask is all I need to do. That's an easy one. I can just do that real quick. Requirements.txt, and we'll say Flask. I can probably just copy that other make file here, which I created in this other project. We'll just go through here and I just want that part. There we go. Install. So I think this is to start with. I think we've got everything working. So if I just say make install, this will install my packages. And I guess I should do the upgrade as well, because it always complains about that, right? So I can change my make file here to do that thing that I typically do, which is in this particular makefile. So if I go back to this, I can make the more fancy makefile step here, which is this step. I'll just replace that. Go here. So we'll just delete this and just swap it out with that. Okay, install. There we go, install. Make install, do it again. And this will just upgrade pip as well as installer packages. Okay, great. Now it's working. If I just type in Python app, or Python main, I mean, it should run it locally. Great. Runs. We got Flask cooking locally here. Now if I click on this web preview icon, it should let me preview the application. There we go. It works. Hello world. And then if I just do this echo, foo, it should do something, right? Don't I have like I thought I had a route here set up. Let's just see what this app does. I believe there's more to it. That if I do echo, echo name. Okay, so let's try that. Let's do echo. There we go. So it just returns back, echoes back, whatever, Bob, there we go, whatever it is I put in there. So we got it working locally. Now the devil in the details here is, we got to push it to App Engine, which has got all kinds of issues potentially. And then we also got to get to continuous delivery set up. So how do we do this? Well, let's go ahead and first do GAE deploy. So I think it's, if I remember correctly here, let's go back again to this app. Hopefully I was smart enough to put the step here. So fork a repo and set up trigger. So I think what we need to do is I just need to look at I have one more repo that has the commands. I should have put the commands in here that will let me do the deploy. And so GCP or GCP ML, hello ML, is this the one that has this commands in here? Yeah, so I need to do, gcloud app create. So, and I'm going to put these into this repo as well. So let's go back here and let's just open the editor now. Let's go into more rapid mode of editing. So I'm going to go here, close this, close this, close this, close this, and then go to this project that I'm setting up, which is again GAE continuous deploy. GAE continuous deploy. And let's go to, we've got the main file here, we've got the app file here. Let's go to the README. And for the README itself, well, that's annoying. Okay, hopefully it lets me edit it. There we go. I was like, what? Okay, so we'll say steps to run. And we'll do this. There we go. So bash gcloud app create. Okay, so let's go ahead and do that. I'm gonna take that and put it into the terminal. There we go, gcloud app create. It's going to ask me to authorize. Sure, let's go ahead and do that. And we'll say central. That's a good choice. And then it's going to go through it. So it's going to behind the scenes now. I believe it uses most likely Kubernetes, and it's going to kind of wake up Kubernetes and do some fancy stuff. And now it says use gcloud app deploy. So let's go ahead and put that step into our README file and do this, gcloud app deploy. And then I will actually commit this change as well. So I'll say get status, and I'll add all this stuff so other people can get access to it, and say initial setup. There we go. And let's push it. Great. So what do I need to do now is do that final step, right? G-Cloud app deploy. Let's deploy this thing. Okay, do I really want to deploy it? Yes, I do. Let's go. And it's going to upload these files. So another reason to put the virtual environment into that that home directory is so that you don't want to check in your virtual environment into something like Google App Engine. It will cause all kinds of problems. I believe it'll just not work, and it'll be really hard to debug what's happening. Okay, this probably will take 30 seconds or something like that to get this working. So while this is working, we're close now, because we're going to have this URL right here that will populate, and we can actually go to App Engine as well, and take a look at what's happening here. So it looks like it's actually going pretty quick. It says your app engine has been created, right? And you can also look at there's a whole monitoring system. I think once it wakes up, it will actually give me the access to, I don't know why it's not showing up here, but App Engine will, although that's a product page, I think this is there's a dashboard where you can actually go to App Engine, and it will show you all kinds of features in terms of like the running application and logs and all this, all kinds of stuff. I don't know why this thing is taking over here. It's kind of annoying, but hopefully it didn't kill. Okay, yeah, it didn't kill my other service. But this thing is almost done. But once it's deployed the first time, it'll give you a monitoring dashboard and all kinds of stuff that lets you see what's going on. All right, should be pretty ready to go here in a second. Okay, looks like it's ready to go. All right, so now that it's up and available, I can actually just go directly into a browser and just throw this in there. And in theory, it should be awake. I think it takes a second for it to wake up. There we go. So it's now it's available, and then I can do the same route, right? I can say echo Bob. There we go. So we got our service deployed manually. Now is the hard part, which is not too hard, which is now let's do it automatically, make those changes. So in order to do that, again, I think I have these instructions set up here in my other repo. So we want to set up a trigger for Cloud Build, and we need to also let Cloud Build be an admin for Google App Engine, right? So that's, I'll actually put this link here to this inside of, actually I'm just going to copy, I'm going to copy this because I've done this earlier. I'll just put this into the same repo. I'll just say this, here we go. And let's go back to our repo here, open up the editor, and we'll just put these comments inside. Okay, here we go. And just throw that in there. And I will save this and then do get status. And let's just check that in. Get add readme. Okay, updating docs. So let's go ahead and do this now. Let's create a file that let's create a file, this file, cloudbuild.yaml file. And so what this does is it actually allows us to do the same commands that I did earlier by the terminal, and I'm going to do it inside of their environment. So I'm going to go back here and say touch cloudbuild.yaml. Just double check here. That's the same file name. Where is that thing? It's called cloudbuild.yaml. Okay, good. Cloudbuild.yaml. And let's edit this. Let's just paste this in. It should look like that. So it's say steps. Whoops. Steps. Name. There we go. Do apt deploy. Okay, that looks good. Now that I've got that, I'm going to commit it. So git add cloud build. Commit this step. Adding cloud build. CD step. Okay. Let's do here. Now we got this thing cooking. That looks good. And what I will need to do now is go to cloud build. And with cloud build, what I will need to do is set a new trigger up. So I'm going to go to trigger, and we will say manage repositories, and I need to add a new repository. So I'm going to say GitHub, and I'm going to say continue. It's going to authenticate, and it's going to be this new one I just created, which is called GAE continuous delivery. So GAE continuous delivery. Let's click on this. Sure, I understand. There we go. So I'm going to create a push trigger, and notice that the build configuration here is that it's going to look for a cloud build file or a Docker file. So Google has actually some pretty good support for Docker file based deployments, but I'm just going to do a cloud build.yaml file, do the push trigger, and there we go. So we got this thing cooking. I believe that should have done it. Let's just refresh here. For some reason it didn't save that. I'll just do it again then. We'll just say, oh no, I hooked up the repo. That's right, I hooked up the repo, and now I need to hook up the push, I believe. Let's just double check. Create trigger. Yeah, create trigger. Okay, so let's go through here and create this trigger. We'll say deploy app engine, and we'll push to a new branch. Every time there's a push, it'll do a new change, and we'll go through here and we'll say that's the one repo that I told it can do. And then notice auto detect. So if you have a cloud build file or Docker file to detect, we'll just say, auto detect, I think is the way to go, and we'll do create. And I don't know why there's that other trigger. It's funny that I don't know why that other one's there. I'm just going to delete this one because we don't need two. And so this one looks like it's enabled. It's hooked up here, push any branch. Now, this I believe will not work. But let's first run it and show that in fact it won't work because we didn't unknown timeout. Well, that's one problem. Unknown field timeout. Maybe they changed that. Maybe we don't need timeout anymore. So I'll go back here and change that. Maybe we don't need that inside of our application anymore. So I'm going to go back to my example here. Go to cloudbuild.yaml, and let's just take this out. Okay. And let's push it, and this should, in theory, git add commit adding or removing timeout. I don't know if they made a change here to what's going on, but let's go ahead and push it. And this should, again, just kind of trigger this, but it still, I believe, will not work because of the fact that we have to set up a permission. Let's go through here. Okay, so it's running. It now at least is working. But look, it says it failed because the service is disabled. And so what I'll need to do is go to this. I think they even give me the URL for it, but I need to enable this this service. I need to tell Google Cloud Build that it has the permissions to actually do this continuous delivery. So as I mentioned earlier, I believe I've set this up in my project under the documentation. Yeah, continuous delivery. This should be in here now. We need to go to Cloud Build and add that. So let's go back here and go to settings and go to service accounts and look, see App Engine. This is disabled. We need to say enabled. And so we also need to go to App Engine APIs and enable that. This is something that I think Google needs to get a little bit smoother. But let's go ahead and do this. I also have to enable App Engine API. So I had to do two things. Let the Cloud Build service talk to App Engine and enable the ability to programmatically access Google App Engine from this particular project. Okay, I've gone ahead and done that. Perfect. Let's go back to this Cloud Build environment. And in theory, because that's set up, let me just go back to it. Let's go make this closer to my environment. Okay, so what I can do now is I can actually go to this file. I believe everything works now. And I can just add something new and just say like, hello world, this is auto deploy now. Auto deploy. Let's try that. And if I press this change, I can go back to history and look, it's now, it recognized that change. And then it's going to go through and it looks like it found that image. We got it. And it looked like it says, you don't have permission to act as a service on this account. G-Cloud app deploy. So I got one more error, which is weird because I thought I fixed that. You don't have permission to act on this service account. Let's try one more time here. Let's see, did I miss something? So I've got App Engine enabled. There may be one other thing that I'm missing here. Is there another? Oh, service account. I also need to enable service account. Yeah, Google is a super fun service to get set up initially. Okay, we enabled that. I'm going to go back here again, and I'm going to try to trigger it again from here. And I'll just go to change the app one more time. We'll say, this is auto deploy, and then we'll say take 2 or take 10 because it takes a long time to set up stuff for Google. Okay, got this working. Commit it, go back here again, go to history. There we go, triggered it again. Hopefully we get a little farther this time. Yeah, so there's like 4 settings you have to configure that are hidden settings that, I think Google should not do that. I think they should have a smoother process. I bet a lot of people just give up and then they never develop apps on Google. But here we go. Here this is. It's deploying. There we go. Looks like it's all cooking and it's working. And the way we can test this out is that it'll show us, I believe, the URL at the end. So it'll take this should be, I think, a pretty quick deploy. and then we'll be able to test this out. So in a nutshell, you can actually fork this repo right here. So you could actually completely fork this repo, and it wouldn't be as hard for you because I did all the stuff that made this work. And there we go. So if we go to this URL like this, let's test this out. Let's go here. It should say take 10. Take 10. There we go. So got continuous delivery set up. Hopefully it was worth the wait.